faculty members, those of you here with us today, and to all of us joining online also. Welcome to the office building division. So the office building division, as we know, is one of the most energy use intensive building type. Now with the COVID-19 pandemic has becoming a distant memory, and most people are back in offices. Our finalist team has put in a lot of hard work. They have submitted their project reports about a month ago. And today, these teams will present their work to the jury. The office building division has 3 jury members with expertise in net zero and resilient building. First, we have Samit Bomik, co-founder of Veratadva. Next, we have Anuja Sawan, principal at SSA Architects. Our last but not the least, our third jury member is Dheeraj Wadhwa, Director of Commercial and Overseas Business at Career Corporations. So these 3 jury members have had about 3 weeks to review the reports submitted by the teams. They have looked at your work in detail and have already assessed your entries for the 10 contests of the Decathlon. Teams, your presentation will help them hear your narrative. They will assess your presentation and your mastery over your solution through the Q&A session. They may revise their score based on what they hear from you today. So I'm excited to have you meet the teams today, and I'll need to interrupt people, including you, from time to time to help us stay on time. So please don't mind. I'm looking for your support for this, and please keep your comments and questions short and to the point. Okay, ready to begin? Yeah, so let's start with the first presentation. So for our first presentation, we have Team Akankse, and they have worked on project Siri. Their design incorporates millet as a building material for sustainable practice and farmer engagement, farmer community engagement. Yeah, so team, come over to the stage. Team, you will have 20 minutes to present your work to the jury. And at 15 minutes mark, I will ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to stop your presentation, okay? End your presentation. After that, we'll have a 10 minutes Q&A. So please keep your answers direct and to the point. Okay, team, the stage is yours. All the best. Your time starts now. Can you turn on the presentation? Yeah. Your time starts now.
Good morning, everyone. We are Team Akankse from Bangalore, BMS College of Architecture and Engineering. Today we'll be presenting to you our project Siri. Our presentation has been divided into 7 segments, and I'll be starting off with an introductory video that will help us set a background to our project.
Employees busy pursuing their daily tasks. Seldom do we visualize the concept of an office in rural India tailored specifically to serve the unique needs of local communities. Thus, the primary objective of our team in selecting the office category was to innovate within this context, aiming to design an office building in rural India that transcends conventional paradigms. Introducing our team, Akankse, a group of 15 students from BMSCA and BMSCE in Bangalore, who, along with our faculty, embarked on a journey to redefine the notion of an office building. Presenting before you, Project Siri, a net-zero rural office and visitor center located in Malavarli, Karnataka, designed to celebrate millet farming and sustainable agriculture. Tree, our project partner, is a farmer-backed company pioneering the farmerpreneur movement. It is dedicated to uplifting farmers to farmerpreneurs, motivating them to aspire more than just the basics of life. We took up the challenge to provide these farmerpreneurs of Malavarli with a formal and professional working environment right in their village, and it became the vision of our project Siri to innovate, sustain, and thrive towards 4 core facets: millets, farmers, health, and sustainability. After numerous meetings and discussions with the industry partners, McDougall, Institute of Wood Science and Technology, Timber Structures Bangalore, and Habitat Studio, our team finally arrived at the present design.
So with the goal of encouraging farmerpreneur movement, our project partner also had few other specific requirements, such as the use of eucalyptus wood as the main construction material, repurposing of a rainwater harvest pit as a sunken built mass, and to obtain a self-sustaining and carbon negative design without the use of HVAC systems. So looking at our climate and context of the site, our site lies in Malavarli, Mandya, Karnataka. It's a part of a bigger campus of Tree, which is 23,600 square meters. And this campus was developed in phases, with phase 3 being our project Siri, phase 1 and phase 2 having manufacturing unit and a processing unit. So our site lies in the warm and humid climate of Mandya. And this was according to ECBC, where we have taken data from Karnataka Meteorological Department, from Andrew Marsh and Meteor Blue. And we did climate analysis based on incident radiation, wind velocity range, and temperature and shading requirements. And these were the climatic factors that helped us formulate the form for our design. Now, moving ahead and looking at our design process, we started off the design by formulating an area program of 1,300 square meters. In this, we had 2 segments, 90% of office spaces and 10% of visitor spaces. Our design process was iterative. We looked at iterative programs where we compared them based on shoebox models, and analysis was done based on radiation, form and massing, and form based on wind movement and daylight analysis. After a thorough comparison of all these different shoebox models and their results, we came up with our present iteration. Looking at the detailing of our present iteration, our zoning consists of 3 functional levels, with the visitor center at the pit, the farmerpreneur spaces at the ground level, and the office spaces at the first floor and the mezzanine levels. To accommodate these areas, we staggered our volumes into 4 levels, and this had a south-facing slope, and this south-facing slope helped us maximize the solar gain as well as to mitigate the high-speed winds. We also had an elevated northern facade, which helped us maximize the daylighting conditions. Looking at how we formulated the interior spaces of our design, all the interior spaces were done based on the program, the function, and the context around. And our underground level had spaces such as the indoor gallery, which we can see here. And gallery spaces don't require natural light inherently, daylight, and they require special lighting requirements. Hence, we had the gallery spaces at the underground level. And on the northeastern corner, we have a multi-purpose space which caters to OAT spaces, and during rainy seasons, it transforms into a water feature. At the first floor level, we have spaces which includes the incubation center and the workshop spaces. These cater to farmerpreneur spaces, and we have a centrally placed circulation core which consists of a lift and a staircase. Moving on to the next level, which is the first floor spaces, we have office spaces as well as incubation centers. We have a conference room that is fitted to the form of our building, and all these spaces are on the northern side. Similarly, on our mezzanine level, we again have office spaces and cubicles. These are on the northern facade because they help us tap onto the natural lighting, and they also encourage better working conditions for the people in office. Moving on, all the spaces we have utilized an innovative material called as lantana particle board, which was done in collaboration with Institute of Wood Science and Technology. Basically, lantana is an invasive weed species which we tapped onto its potential and we utilized it to form a particle board, which has been used for fenestrations and multifunctional furniture. This multifunctional furniture reduces the extensive use of furniture as well as encourages versatile utilization of spaces. Moving on.
Okay, so moving on to materiality and construction. Before we started off with the construction or thinking about materials, we thought of looking at how different materials in terms of innovative materials like Melia dubia or eucalyptus being the main structural wood and mod panels, vegetal concrete, etc. So we have done the phasing of construction in different steps. First one being at the pit level where we have concrete and steel being used only here. And then we erect the eucalyptus columns. Next, we go to the retaining walls where all the retaining walls are done with vegetal concrete whose main component is millet husk, which is from the manufacturing unit. And this helps as a planter box as well. So moving to the next step where we have construction between the eucalyptus columns in terms of rammed earth. And these rammed earth are separated from the wooden columns with the metal members, which helps in reducing moisture and also separating it from a termite infestation. So next, the main building form is in terms of eucalyptus treated wood, which is then treated with cashew nut shell liquid, which makes it moisture free and also termite resistant. And all of our joineries were done in collaboration with architect George Lusinger, who helped us design these joineries. This was the joinery that we have worked out. And all the beams, columns were done with detailed scalability in terms of how it sits within the grid. So these weaving method is what we've used for the columns and beams. Moving to the roof assembly, for purlins and rafters, we've used eucalyptus, above which is the millet husk insulation of 125 mm, which is encased in a Melia dubia lattice, and then above which is the mod panels. So all of these different construction techniques have been maintained, and it helps during construction through our proposal of Trimble Site Vision, which is an augmented reality software which helps it easier for the construction as well as for the maintenance. And this, the data, the model that we need to give is through geospatial data, which we upload it on their website. And this can also be accessed by the clients and during construction through a cloud-based system. So moving on to passive strategies, we have utilized the double glass facade as a solar chimney, where we see that due to temperature difference, there's a pressure difference created, out of which our hot air automatically exits out. So during summers, we require 12 degrees or more temperature difference, and this has been tested through CFT analysis as well. And during winters, we make use of centrifugal fans where the temperature difference is not met, and even this was tested using CFT. So moving on to the next system, which we have wind towers. So the wind towers help in bringing in air throughout the structure. And for the air influx, we've used terracotta lattice, which compresses the air and makes it much more cooler as it enters. And all the fenestrations have been designed as a pivoted windows, which helps in achieving a 30% window to wall ratio. And these are placed on east, west, and the southern facade to achieve cross ventilation. And since we were mitigating HVAC systems, it became very important for us to kind of test out the ACH or the A-cycle changes, which we kind of did with Design Builder through the CFM that we got. And we've achieved 7 ACH in most of our spaces. And operative temperatures, we are within the range of 19.6 degrees Celsius in Jan to the highest temperature of 35 degrees Celsius in May. Moving on to natural ventilation, we are achieving wind movement of 0.5 to 1.52 meter per second within the structure, which is enabling thermal comfort. And in terms of humidity, we have 30% window to wall ratio, which is reducing the humidity. And the thermal comfort ultimately is 77% of our annual hours, working hours for the occupants achieved. So the the entire structure is daylit. So our main source of daylighting was through the double glass facade and through the north lights in the southern slope. And the inclination was decided based on the azimuth angles from the summer solstice. Moving on to how we ran different simulations. In terms of daylight autonomy, It's 300 lux minimum achieved in all office spaces, and annual sunlight exposure, 98.12% of the area is receiving 1000 lux, which is again within the discomfort range. Moving on to illumination, we have 300 to 500 lux in all office space, and in the pit level, like she mentioned, we are achieving a little lesser due to the functional requirements. And 90% of our glare is imperceptible, and the rest is managed with the wooden fins in the double glass facade. Yes, going on.
Moving on to building performance, this will be in 3 parts. So first I'll talk about energy, then water, and then the embodied carbon. So our goal for energy was to achieve a naturally lit and ventilated space, and for this we considered 300 operation days for the office per year and 365 operation days for the visitor center per year. So we began with a Griha benchmark of an EPI of 75. We used passive strategies and brought it down to 22.55, and then we used active strategies and implemented them, which brought down our EPI to 10.79. So we achieved a total reduction of 47.8% from passive to active strategies. Coming to our envelope optimization, as the materials I mentioned before, we achieved a U value of 1.9 for our rammed earth wall. We had, this was in the pit, so it allowed for thermal comfort. Then when we looked at the roof assembly, we looked at different kinds of combinations of materials, and we fixed on mod panel, millet husk insulation, and Melia dubia panels. When we come to the second part of the wall, it was consisting of Melia dubia panels, an air gap in the middle, and eucalyptus lattice on either side. Coming to one of our more important aspects, the window, the north facade itself, has 8 mm clear glass on the internal side, and it has 10 mm performance glass, which is low E and low carbon performance glass that reduces all the glare and achieves thermal comfort inside. Coming to our active strategies, we have occupancy sensor lights and BLDC fans. Occupancy and lux sensor lights are only used when required and when the daylighting is not sufficient. LED strip lights also help reduce the amount of energy consumed, while BLDC fans reduces the energy by 60%. When we look at our macro scale of things, our total energy consumption is 14,000 kilowatt hour, and we use 32 solar panels to generate 33,000 kilowatt hour of energy on site. This energy is then given to our grid and then returned back for our consumption. We've taken 5 peak hours of sunlight, daylight every day for all our calculations, and we have a 10 kVA capacitor on UPS capacitor on site for days of autonomy. We achieved 3 days of autonomy. Now we come to the water performance. When we're talking about water, we wanted to design a net water positive structure, and for the office population, we achieved 23 LPCD for 45 workers per day and 5 days a week, while visitors was 15 floating people, and we achieved 13.8 LPCD. We have the water cycle as shown and as you all would have seen. And we use strategies like drip irrigation for landscape and nanofiltration technology for rainwater. This helped us make rainwater accessible for drinking. When we have a reed bed STP system on site, on the campus, and hence the water that is used goes to the STP system. The wastewater is then used only for, the wastewater is only used for flushing and for landscaping. The 5 months in a year, we receive below required rainfall, and for this we use 85,000 liters of groundwater. We also give back the excess rainwater and excess treated grey water and black water that is for that returns to the ground, and this is 7 times the amount that we're using from the groundwater. We have a percolation pit on the ground floor. This helps us prevent flooding. This is the entire table that has the water balance of our entire site. 3.54 lakh liters is our total consumption per year. And here we can see how we're recharging our groundwater by 7 times the amount we're using. We achieve a total 57% reduction from NBC baseline in terms of our water consumption. Coming to embodied carbon, our goal was to design a net carbon negative structure and locally source all the materials that we've used for our structure. So we considered a base case scenario which has concrete and brick and the conventional materials that you would think of, and we compared it to our proposed case, which was of eucalyptus wood, Melia dubia, millet husk insulation, etc., we achieved a total reduction of 122.4% in the overall carbon, and we've procured and achieved all the materials which are locally sourced from within 2 to 75-kilometer range, including manufacturing, processing, procurement, etc. We also used one-click LCA software to analyze the life cycle analysis. This considers upfront carbon, operational carbon, and end of life. Operating carbon is a much lower value since it also considers the amount of energy that we're generating on site, since we are generating excess energy and giving it back to the grid. We also looked at SEMA Pro software, which was done in collaboration with Ms. Swati Mishra, who helped us from the Institute of Wood Science and Technology. Here we assess the baseline and proposed case for the overall carbon utilization and the overall impact it has on the earth. So to summarize this, we had an EPI of 10.79 EPI. We reduced water by 57% from the NBC baseline, and we had a 122.4% reduction in carbon emissions.
Okay, so coming to resilience, so the 4 main strategies that we have incorporated in our building include the incorporation of vegetable concrete planter blocks for the retaining wall, using MS joineries and concrete to separate the timber from the ground soil, inclination of the roof in the south axis, and the incorporation of a percolation pit. The building has the capacity to sustain on its own reserves in case of any shortage for 3 working days on electricity and 17 working days of water. Coming to value proposition. Value proposition mainly deals with the reason as to why a customer should invest in a product and what return he gets from it. So the major stakeholders of our building include the villagers, visitors, the project partners, and the farmerpreneurs. So coming to the value for villagers, they get an increased employment and awareness about millets. Coming to the value for visitors, they get education about millets and a pathway to communicate with farmers. So moving to the value for the project partners, they get a building which is energy efficient and water efficient, and also a building which is has a reduced cost and higher affordability rate. So coming to the costing aspect, we have managed to achieve a 28.1% reduction in cost compared to a baseline. This is due to the incorporation of innovative fixtures and also due to the implementation of solar panels, which decreases our life cycle cost by 64% as well. So coming to the construction timeline, our construction period spans over 6 months. This is mainly due to the fact of wood being sourced. This can be reduced more by the source of pre-season wood by 8 months. So coming to the value for farmerpreneurs, the main objective of our project is to create an avenue for even the educated population of Mallavalli to showcase their skills which are not related to farming through the app. So this is achieved through the Akankse app, which allows farmers from various localities in India to collaborate and innovate on ideas. So coming to summarize, the major achievements that we have achieved in our project include energy performance and EPI value of 10.7, which is very low for an office building. Water performance of 57% reduction in water consumption, 122% reduction in embodied carbon, making it a carbon negative design, and also a 21% reduction in affordability. So to summarize, we have a small video. Our team as a whole believes in the vision of providing facilities for farmers, allowing them to innovate and grow through creative ideas. The movement, farmerpreneur movement, which is coined by our project partners, allows farmers to innovate. This is done through the app, through various localities in India, helping them to grow. Thank you.
Thank you, team. You finished well in time and great presentation. So now let's hear it from the juries, their questions and comments. So for the Q&A, you'll have 10 minutes, and that is your limit, okay? Yeah, so first we'll hear it from Samit. We'll start with you. Yeah, and your starts now.
You're timing me as well. Excellent presentation, very good work done. I think the very fact that you have looked at materials and localization of our idea, I think it's commendable. A lot of good work done on this project. I'm an engineer, so I'm always looking out for engineering in the structure, in the presentations. So just a couple of observations. I don't want to put them as questions now, but a large part of this will work out is going to be the thermal comfort, right? Because you're trying to eliminate air conditioning, all of that thing. Great idea. I would have loved to see a little more effort on demonstrating or giving the your project partner the confidence that this will work without any air conditioning. For example, the solar chimney, I think you had a very fleeting reference to that. I would like to see a little more effort on that. A little more effort on probably, for example, I mean, the entire airflow is driven by your facade and the heating on the roof. And this is also north oriented, so you're going to get less radiation on this side. So a little more effort on that. This would have been a fantastic effort, but otherwise excellent effort. All the best.
Okay. I'll continue with the same thing. It is really a good work. I just have one kind of a question that I could see a lot of innovation as far as material is concerned. But when as an architect, I look at the innovation at the same time, I have to look at the life cycle. And when we are looking at the farmers and the maintenance of these materials, how the life cycle was analyzed by you while proposing these material. And second question is the ramp earth is currently more towards the areas where there are rivers. So getting these layered sand is a special job. So for such a very cost sensitive and when you are talking about a carbon, from where this material you're thinking about getting it onto the site? Or if you're talking about this module being in overall India, the lantana board could be a very special material. So when you're making it modular for across India, what was the thought? That is just a question. Otherwise, all the best and it's fantastic presentation.
So ma'am, regarding the life cycle of our structure, so say for the wood itself, we looked at, like we spoke to the Wood Science Institute of Technology. So they, along with Mr. George, helped us with the life cycle. One is Melia dubia has very less term, it is not affected by water as much, and it is not as easily affected by termites, as we've spoken. And Institute of Wood Science Technology, Dr. Anil Sethi, when we spoke to him, he said, as long as we're using the cashew nut shell liquid, we are able to have a life cycle of service life of 100 years. We've still considered it for 50 years in terms of our analysis.
And with respect to, say, maintenance, the system that we have used, the Trimble Site Vision, easily helps them monitor how different material or when the last maintenance was done. Say, for suppose the spraying of the treatment done for it, when was it last done and when will, next it should be done. And even in terms of, like you said, rammed earth is not really, widely available and it can't be done everywhere. So here, the reason we chose rammed earth was, first thing is it could become one monolithic wall and not adobe brick. So we were just we had a lot of discussion to have an alternative after receiving the comment saying that why did we even choose this over adobe bricks. So we thought of that and then we were like, okay, we will have a monolithic thing because of course wind also is affecting the structure. And even in terms of availability of the river sand, there's a river which is just 16 kilometers from the site. And all our transportation, even for carbon calculations, were done for it so that it's within that radius and it's negligible amount for carbon calculation.
Also, when we talk about soil for rammed earth construction, we know that we need red clay soil, and the Mysore Mandya region has a lot of red clay soil. So there are also sources pretty close to our site as well as in situ sources. So that's why we have opted for that.
In terms of costing, when it comes to life cycle analysis, the only cost which was added due to the material being selected was the recoating of the walls, which has to be done periodically every 5 years. So that was one point I wanted to add.
Yeah.
Ma'am, one more part of your question was how we implement this in different parts of India. So we implement the strategies more than the materials itself. So we look at where we are able to find any available materials in that space. and the same strategies we could use.
Over to
Fantastic
you.
work. First of all, clarity of thoughts is what I appreciate, and its implementation on the ground is visible to all of us. Questions which I have for you are a little different, not related to your project directly. Would like to understand how did you find your industry partner contributing to your work? Okay, I'll have three parts to the question. Industry partner. Second is, how do you find your faculty contributing to your project? What did you learn from them? Third is, what did you pick by yourself after these two? So this is one question, but three parts. I have got another question. Please answer this one first.
Okay. So before we even started off, breaking this brief of Solar Decathlon, since last year our college was the first time they participated. So our faculty mentors were, I would not call them faculty mentors, they were our team members, because the dedication that they have put in from beginning day one, from September till today, we've all been together as teammates. And coming to how we chose project partners, we kind of contemplated a lot as to what is our vision, and we didn't stick to office before. So we wanted to do something very different from what is conventionally done in Solar Decathlon. So we started off looking at different projects. Then we thought that, okay, in terms of office building, there were few projects that we basically met a lot of project partners. We met around 6 to 7 of them, and then we later chose this, saying that in office this perfectly fits in, and it's very different from what all office building projects have been done so far. And in terms of say how industry partners have helped us through, is one thing is we made sure that there is a lot of stakeholder involvement in this, because the moment we met our project partners, day one was, of course, Solar Decathlon was one aspect of it, but they were very realistically looking at building this project, and that professionalism came to us the moment they had that professionalism with which they presented the brief to us. And they were very clear with certain aspects, because the manufacturing unit right now is net zero. So they wanted a very similar character and very similar nature for our office. And of course, we had a lot of meetings with them. All of this is a result of stakeholder involvement, and a lot of meetings with them helped us grow it more.
What did you pick by yourself?
Okay, so things that we picked by ourselves was, they were say for suppose they wanted to create benchmarks or records in terms of the contest. Say we have done carbon negative structure. SDI asked for carbon neutral. We've done carbon negative, that was by ourselves. And then EPI reductions, we were given a target to have around 15 to 20 EPI, but we have tried to got it down and trying to claim it to be one of the lowest EPIs. And in terms of material exploration, the moment we met Forest Institute or Sir George, we kind of got to know how these details were done, and all of these details project partner didn't really expect us to go so much in detail for the joineries per se. So all of these were done as part of our team's efforts.
Okay, thank you. No second question, Manish?
We only have like 1 minute, but if you can fit in. Yeah.
I will. So my question is connected to what Anuja asked a minute before. How can you replicate this kind of a setup in other parts of the country? I'm just restricting it to one part of it. See, the construction part will help you get to the net zero from a embodied carbon perspective. But a part of it is connected to the air conditioning, because the concept what you have adopted is a novel one. How can this be replicated in other parts of the country, considering our nuances around the climate changes, what we have within the country itself? We have got 9 types of climates in the country today. If you have not done some work, I will encourage you to do that work and figure out, because this is very good. It will help the country, not just the project. Okay, if done, help me understand in case you can. That's all.
So looking at how we can implement it in various parts of our country, already having different climatic conditions, though we have mitigated the use of HVAC systems, the use of solar chimney as such will help us accelerate the air cycle changes. And in this, basically it works with temperature difference, but also we have a accommodation for centrifugal fans, where if the temperature difference between the indoor and the outdoor, the 12-degree difference is not met, the centrifugal fans will start working. So that's how the exit of hot air happens.
Thank you, team. Your time is over. That's it.
Okay.
Yeah.
It's okay.
Thank you, jury members, for your comments. Yeah.
Thank you so much.
Yeah, so we'll take about 5 minutes and get ready for the next presentation. So team can prepare. Okay, everyone, ready to begin? So our second presentation is from eCube. They have worked on project Infosys. They're building leverages radiant cooling technology to meet LEED and Griha standards. It's situated in Indore, Madhya Pradesh. Yeah, team, you can come up to the stage. Team, You will have 20 minutes to present your work to the jury. And at 15-minute mark, I will bring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you to ask you to stop your presentation, okay? After that, we will have 10 minutes of Q&A, so please keep your answers direct and to the point. Okay, team, the stage is yours. All the best. Your time starts now.
Good morning, everyone. We are Team E-Cube, representing Vivekanand Education Society College of Architecture and Institute of Technology. The approach of the team was not only to achieve certain numbers, but keeping the design user-centric and focus on the holistic development further. Our project partner is Infosys, and the site is located in Indore, Madhya Pradesh, which means the climate is composite, which faces extreme temperatures. The total site area was 5 lakh square meters, out of which the permissible built-up area was 36,000 square meters. The ground coverage was 7,200 square meters.
To give you an overall gist of the project, the architectural design was mostly governed by the site, context, and the user. Energy performance, we were able to achieve an EPI of 57, which is about 76% reduction from the base case taken from ECBC. We were also able to reduce the embodied carbon and water by almost 50%. Our design focused on catering to the health and well-being of the user, as well as creating a resilient design. There were tangible and intangible benefits which catered to the user as well as the stakeholders. Moving on.
As I mentioned earlier, the site is situated in Indore. It is situated in the prime location. That's why procuring the materials was within 20 kilometers from the site. It is situated in an IT hub also. There are agricultural fields on the west side of the site. It is abutting to the super corridor, which is a highway. Starting with the architectural design, we started with user-centricness was our focus and the core concept of the design. We firstly we studied the timetable of each and every user who is going to be using this building, from VIPs to the staff members as well, and keeping in mind their needs, we have designed the spaces accordingly. Studying the bioclimatic chart, we came up with the EVA strategies like light well and light shelves for habitable spaces, evaporative cooling for unconditioned spaces, and night flush ventilation helped in reducing the energy demand. Also, after doing the cultural study of Indore, we integrated community spaces like kiosks, innovative solutions which helped us move towards net zero, and sense of belonging to the space to the user.
On studying the culture of the Indore and Indore city as a whole, we realized that Indore is a vibrant and a lively space. Spaces like Chappan Bazaar and Sarafa Bazaar contribute to the beautification of the city, their food and culture. We wanted to integrate this into our design. So we basically started with erecting a rectangular mass on the site, which was chamfered from the south in order to minimize the heat gain on the southern facade. Later, we created a niche on the eastern facade to create a self-shading entrance. Since a major wind direction was from west, we created another niche on the western facade in order to acquire the wind pressure on the western facade. While zoning vertically, we started zoning from public to private spaces. So public spaces, say banquet, dining, and kitchen, were placed on the lower floors, and kiosk, which is a modern take on Chappan Bazaar, Sarafa Bazaar, that was placed on the first floor, which is a semi-public space. Later, the central core, which is a public space, has informal breakout spaces for the user, and the private spaces were placed on the periphery, that is the office spaces and cabins. We have provided a central light well in the center of the building in order to provide light, light inside the building penetrating. We have provided light shelves, and we have also provided a wall to window ratio of 30%. Moving on.
As she correctly said, Indore is a very vibrant city, and and the Chappan Bazaar and Sarafa Bazaar were actually something which caught our attention. We wanted to give wanted to give our take on those aspects. So we have created pathways and entrance of the building in such a way that the interaction of user will be maximized. Also, the kiosk space it will be designed in the keeping in mind the vibrancy of the Indore.
Now, why just leave green? Why just build green? Why not leave it? Is one thing that come to our mind when user analysis. So we have generated an applications where users can track their carbon by answering certain questions about their commute to the office. Lesser the carbon footprints, better for the users, as this will provide incentives for the kiosk and the gym vouchers. The main intention of the app was to change the lifestyle of the users and make them more aware about the environment.
The unique selling point of the design is the facade which we have innovated. This facade is placed on the western side of the building, wherein after doing the CFD analysis, we got to know that there is a gush of wind of 7 meters per second, and we got this opportunity to not only generate energy, but to also provide comfort in unconditioned breakout spaces. This facade consists of fans on the outer side and wind wall and water wall on the inside. As the wind will flow, fans will generate the energy, and by evaporative cooling strategy, comfort will be achieved by the user sitting in the breakout space. Our industry partner, Ventic, helped in calculation of evaporative cooling and material selection and affordability aspect of the innovation.
So for the hydrovent facade, there is a steel frame which is located, and there are columns, individual columns that are supporting the vibrational load. The fan is positioned in such a way that when the wind is flowing through it, the fan is positioned on a vertical axis which is connected to the pivots, and it is powered by dynamo motors. So the water wall behind the fans, it is at every intervals of every 2 floors. So we have incorporated bird mesh to ensure the safety of the birds. The system is connected to BMS system to ensure a controlled management. The proposed HVAC uses closed coil loop system, which closed coil loop radiant system, and dedicated outdoor air system for ensuring supply of fresh air. In warmer, during the month with the temperature droppage of 15 degrees Celsius, the DOAs provide fresh air to ensure a comfortable indoor environment, and in the warmer month, it provides cool air. In colder periods, the DOAs remain inactive.
In the months like November and December, wherein the temperature actually drops in Indore below 15 degrees Celsius, radiant cooling system will remain shut, and DOAs will be working, in which instead of the cool air, hot air will be buzzed and heating will be ensured. Energy performance of the building. The team firstly looked upon with the start of the design itself, that is the form development, material selection, envelope, and window designing like recessed windows and proper shading. Also, these were the passive strategies which helped us to achieve, or we can say to reach, the energy performance index of 103. Further, Further, active strategies like efficient fixtures and efficient lightings helped us to reach 57 energy performance index, which is reduction in 78% from the base case. To mitigate the rest load, we are relying on the hydrovent facade, which we just talked about, and solar panels. Hydrovent facade is contributing 36%, and 64% of the load is mitigated by the solar panels, and hence in this way we are achieving net zero energy.
In order to reduce the water demand, we started with using efficient fixtures for the building. Through this, we were able to reduce the consumption from 45 liters per person per day to 20 liters per person per day. Further, we also started looking towards landscape by planting native species and using drip irrigation, xeriscaping. We also decided to treat the water on site through MBR, which is we will be treating the grey as well as the black water on site. For the potable water, we will be procuring that from municipal, whereas the non-potable water for washing, cleaning, which will be used from bore wells. For rainwater harvesting, we are basically harvesting the rainwater in two parts. The first is an existing pond on Infosys campus. For the water collected in this pond will be used for the hydrovent facade for the evaporative cooling. Next, we are planning on proposing to construct a UGT which will house about 5,000 kiloliters of water, which is the annual rainfall on the site, so that we can store this water for situations like drought. We are also planning on recharging the groundwater through recharging the ground through recharge pits and the bore wells basically.
We have analyzed the GHG emissions both from direct and indirect sources. So based on that, we present to you the carbon compass, which is our innovation, which is helping the user to practice sustainability, and it also raises awareness among the users to create to promote sustainability. So by using recycled steel and recycled cement, we are reducing the embodied carbon by 42%. We are sourcing the materials directly from the manufacturer within the 20 kilometers of our site area. So our contribution to promote sustainability includes using eco-friendly materials such as EcoBoard panels and cellulose insulations. We have focused on the health and wellness of our users by considering several aspects such as physical, mental, emotional, and social well-being. Through thoughtful design, we have prioritized user comfort and occupants' need by offering them comfortable temperatures, clean indoor air, and visual elements to enhance productivity. Our diverse program aims to support the holistic well-being of the users.
For resilience, we started out by the preliminary precautions for food, water, energy, and waste. So for food, we are proposing culinary farming on site itself, and we are also procuring grains, food grains from the neighboring farmlands. For water, we have constructed a UGT of about 500 kiloliter capacity, which will provide an autonomy of 7 days. We are segregating waste into dry, wet, electronic waste for IT campuses, so we can treat the organic waste on site itself through organic compacting machine. Energy, we have a 3-day autonomy through DG generator. An alarming threat to the site of Indore is heat waves. So at site level, we are tackling this through planting trees and creating shaded pathways so that these spaces are comfortable enough for the user to walk in without having heat stroke. At building level, we are tackling this by envelope optimization, by using shading devices, in order to, we are using cellulose insulation for the walls, and for the roofing, we are using mud pushka, which is a traditional technique used in Indore. In order to reduce the structural heat, we are using radiant cooling. Another threat is droughts. As I said, the water which we are preserving from the rainwater harvesting will be used during droughts. so that the water demand is met during such condition. The building is fire compliant, and we have provided an ECC block for the users right next to the building during pandemics.
Talking about affordability, as we said, we have proposed radiant cooling system in the building. 14% reduction in life cycle costing of the system is seen. Also, we have done the benefit to cost ratio for the proposed hydrovent facade. It came out to be 3:1, and the payback period for the facade would be 2 years.
We Team ECube present to you a 5-star Griha rating building focusing on 10 out of 17 sustainable development goals by the United Nations. The project try to maintain the balance between the 3 pillars of the sustainability, which is environment, equity, and economy. We provide benefits to the stakeholders and as well as the users, like energy and water efficiency, resilience and design comfort, resilience in the and resilience. So we like to thank you, Solar Decathlon India, for providing us this platform to present our project in front of the jury members. Thank you.
Thank you, team. Thank you for finishing, 3 minutes early. Yeah. So let's hear it from the jury. Again, we'll start with Summit. Anybody? I think we'll start with Summit. Yeah.
Thanks, team, for the presentation. I know it must have taken a lot of effort, so you can relax a little bit. Again, I know you, couple of just observations. I know you talked about radiant cooling system. Why did you choose a radiant cooling system? Why not so many other systems which are there in the market? And also, I didn't see anything about, the cooling load calculations in any part of the presentation. So, what is the cooling load of this building?
So why we chose radiant cooling system was when we got brief from Infosys, it was mentioned that in this campus they are actually proposing other buildings, they are proposing radiant cooling systems, and we thought it would be efficient if we go ahead with it. And capacity of the cooling capacity of this system is calculated in the report. The cooling capacity is 573 kilowatts.
Because there's a student competition, you have the liberty to look at multiple technologies, right? Don't get stuck on what your project partner tells you. You have access to technology, you have access to simulation tools. There's a lot of help from here. I can really encourage all of you to use the opportunity you've got here to explore new ideas, right? That's what we're looking for here. But anyway, thank you so much for that effort.
Thank you.
Thank you for the presentation. My question to you, you must have done a lot of case studies of the commercial footprint. And typically, if you observe, the commercial footprint will always look for the central core rather than the peripheral core. But I found peculiarly in your plans, you have gone for all the cores were spread out at the periphery and the workstations were in the center. So when I look at that and then this particular linear form, see, first of all, when the architectural layouts are efficient, or when you look at all these efficiencies, that walking distances for the people, once architecturally we look at the efficient floor plates, your results are going to be much more efficient when it comes to any sort of analysis or your facade areas. So I just want to understand any specific reason why all the cores are at the periphery, which could have made your floor plate linear if you could have utilized more of a facade areas. I understand the heat gain, but there were several strategies by which you could have worked wonderfully on the facade. and innovated much more. So, what was the reason to have the peripheral facade and the central office spaces with a lesser daylight?
So the idea was that, like, for example, the toilet blocks or the lift. So the idea was that they should be accessible to everyone sitting inside the office spaces as well as outside. So giving it at the center would restrict the access of some of the users. So we also gave a common core area in the center as well as a core area on the periphery, since the floor plate was used.
Okay, just to guide you a little bit, even if you place it in the center, you could achieve the central distances. But it's wonderfully, you could work on the facade where the office spaces can be further subdivided. So that's where you get much more flexibility. So it is just a comment and some guidance to you in the future. So wonderfully, you could have reduced the floor plate. It could have become slimmer. Less is more. You could have got wonderful results in your design.
Right.
So that's just observation.
Thank you, ma'am.
Nice to see the effort behind the presentation which you all did to us, and happy to learn about your thoughts around it. I will echo Samit's words first and then go to the question. There's a platform wherein all of you, not just you standing on the dais there, but every one of you who are here as students, an opportunity for you to learn, for you to challenge yourself, for you to challenge your project partner even. Don't go by what they feel and they know is good. We look up to you as student community who will give us a lot more ideas. You know, we sitting here in this position as jury is by virtue of experience only, but we are also hungry for ideas today. Equally hungry, more hungry. And we look up to this community, the student community, from all of you. And having said that, it would have been wonderful had you challenged your project partner on that. I had asked this question also in my report that, you know, did not see a configuration, total capacity requirement, etc., etc., efficiency of the equipment chosen. I did not see that again on the slides also. If you have an answer, I'll be happy to hear that. One, just to answer, I remember, was it 500,000 square meter project size? Yeah, 500,000, 5 lakh, that's okay. Cannot be 570 kilowatt of cooling capacity for that kind of floor plate. I can tell by experience, and I cannot be that wrong. So we'll have to recheck on that for sure. And that's what I say, challenge yourself, don't worry about it. We are all here to learn, we will keep learning. Second is, I also had asked a question that in your base case versus fresh case, how did the cost optimization of land happen? Did not see an answer to that as well. Could you help answer that?
I think that was a mistake from our side.
Okay, that's okay, no worries. So we keep learning, don't worry. And thank you and appreciate the effort which all of you have put in to get to this, to learn all of things and keep learning. Thank you.
Thank you, sir.
Thank you, Team eCube. So we've had our first two presentations. Can we give a big round of applause for them? Yeah. Okay. Yeah. So we'll have a 15-minute break. So and then we can continue with the third team. So there'll be tea stand outside. You can have teas while we wait. So yeah. which is sort of like situated in a extreme, dense urban location, and their building, sort of aims to create, great building as ecosystem through their, sustainable design. Yeah, team, come up on the stage. Team, you will have 20 minutes to present your work to the jury, and at 15 minutes mark, I will ring a signal like this. You won't have a 21st minute, so be mindful, which means at 20 minutes, I will stop you and ask you to end your presentation. So after that, we will have 10 minutes of Q&A session. Please keep your answers direct and to the point. Okay, team, the stage is yours. All the best. Your time starts now. Can you start the presentation? Yeah. Aim to it. Yeah, so your time starts now.
Yeah. Good morning, respected judges and my dear friends. We, on behalf of Team Unix, will be designing a we, on behalf of Team Unix, will be explaining a design, Kohinoor Edge. Our team comprises of members Janik, Preksha, Durva, and Shivani, who will be presenting the project and making the design more sustainable. Our site is located in Mahim, which is nearby to the coastline of Mumbai. The Kohinoor group has projected a large-scale cluster redevelopment in this area. Our site comes up with its own strengths and challenges. It is surrounded by water bodies, mixed-use buildings, and vegetation. Because of the enhancement in the connectivity, the users feels an ease to travel. Riverfront is being proposed on the northern side of the site that aims at becoming a sustainable and a social gathering point. Office spaces in the building will be leased out to maximize the potential of the site. Spaces are designed in such a way that enhances the comfort as per ASHRAE standard 55. The site given to us was 6,850 square meters. According to the cluster redevelopment program, the FSI given to us is 5.4 with a permissible built-up area of around 36,000 square meters. We are including 22 floors in the FSI, and the total height of the building is around 92.4 meters with occupant density of 3,423 users. Synergyscape is an introduction to nature and building simultaneously that focuses on mental, physical, and social well-being in the building. This is the chart that shows the unconditioned and conditioned spaces. To maximize the potential of the site and get higher returns, we have managed to give more number of office spaces to mid-range offices. And hence, the last option we have derived, which gives 23% of the spaces to the office spaces, to the mid-range offices, and for them to flourish. Initially, shoebox analysis was performed that tells us the exact orientation of the building. The site is taken with an offset of 6 meters according to the DCPR norms. The core and the services are exactly oriented on the south facade to further reduce the radiations. Elements on the east and west facade are added that further reduces down the heat waves. Curved screens are added on the south facade that allows venturi effect in the building. This is our final form. We have solar roof on the terrace, and due to the increasing heat waves and to make the building more resilient, we have added green screens on east, west, and south facades. The landscape has maximum amount of gathering spaces and an infinity corridor. We have created a buffer zone between the vehicular entry and the pedestrian movement. The basement is being provided through the periphery of the building with a slope of 1:10. The entire ground cover is kept porous for the pedestrian movement. Spaces like kiosks, amphitheaters, and multiple discussion pods have been added to allow the community gatherings and interactions in the space. Coming on to the typical floor plan 1, which ranges from 1st floor to 6th floor, we have added 4 chamber offices and 2 mid-range offices with a linear corridor connecting in between. On the typical floor plan 3, which ranges from 18th floor to 22nd floor, we have added 2 high-range offices with a common lift lobby in between. The offices and the interior cabins are placed in such a way that they are placed internally and the entire office is kept open for natural light penetration that enhances the user productivity. Spaces and the desk, there are different types of desks that are used, and indoor air quality also is being taken care of in the spaces. These are some spaces that are designed along the refuge areas. The section of the facade shows that we have added Tipco wood, which is climate resilient. The whole facade is being made up of Tipco wood, and the solar panel is rested at an angle of 45 degrees that will further cut down the radiations entering the building. The flower bed as well as the pivoted windows are an integral part of the facade system. The maximum building systems are there on the basement floor, which includes rainwater tank, UGT, and MBBR systems. On the refuse floors, we have service areas and database centers. On the terrace floor, we have restaurants, lounges, and a solar terrace along with the chiller systems.
In the realm of energy conservation, we have meticulously optimized every aspect of energy, from lighting loads to cooling loads. Hereby, our total energy consumption comes up to 30 lakh kilowatt hour per year. From this, 13 lakh kilowatt hour per year is utilized for HVAC alone. However, our commitment to sustainability doesn't stop here. With using materials such as paved and tiles generating 5 lakh kilowatt hour per year, solar energy generating 16 lakh kilowatt hour per year, and wind energy generating 77,000 kilowatt hour per year, our total energy generation comes up to 22 lakh kilowatt hour per year. This adds up to 75% to net zero. Considering the IGBC guidelines, 225 EPI was taken as a base case. Considering the radiation analysis, chamber offices and mid-range offices were placed such that they optimized the northern facade. Further, green screens were placed at different intervals to reduce the internal radiation up to 230 kilowatt hour per meter square. HVAC spaces were further reduced to reduce the HVAC and mixed mode of ventilation was utilized to reduce the HVAC loads. Insulation boards were provided in the walls, in the ceilings and floors, as well as DG glasses were utilized to further reduce the heat transmission and reduce the internal radiation. Our shading devices were at an angle of 45 degrees to reduce the internal radiation of the building. Energy efficient fixtures like lights, elevators and pumps were utilized to reduce the overall EPI to 110 from a base EPI of 225, that is 49% of reduction. However, the maximum energy consumption is in the month of April and May. That is because of the increase in HVAC loads. HVAC in our building consists of chiller systems. This is used because of the centralized cooling system, efficiency and integration with renewable energy. Thereby, it brings our HVAC load up to 800 tons per day. Our HVAC chiller system consists of 3 chillers of 400 tons each, including 1 backup. It includes 3 cooling towers of 500 tons each. We also have individual AHUs in each offices and VFD system to regulate fresh air. Paved and tiles are located on the lobby area, generating 5 lakh kilowatt hour per year, whereas solar panels on the facade generate 9 lakh kilowatt hour per year, and solar panels on the rooftop generate 6 lakh kilowatt hour per year.
Coming on to the innovation part, we'll also have electricity generation through Venturi effect in our building. Initially, the linear geometry of the facade allows 1.2 meters of the wind entering the space. Further, to take advantage from the coastal winds, we have added curved geometry that allows 2 meters per second of wind entering the corridor spaces. Lastly, the plan is aligned at parallel to north direction with a funnel getting created that allows suction and brings the speed of the wind to 4 meters per second in the corridor spaces. We have calculated monthly, and monthly calculations were done to understand the energy consumption through the wind turbines. That sums up to around 77,978 kilowatt hours per year. The green desk is the bridge between innovation, nature, and human. The drinking water is being recycled in this situation, and the product is made with least carbon with materials like aluminium, recycled plastic boards, which cost us around less than 15,000. That is more affordable and it can be recycled as many as times as possible. We have catered to 5 aspects in health and well-being part. The plants allows the air to purify and maximizes the oxygen level in the spaces. Recreational spaces have been added on the ground floor that acts as a breakthrough during long working hours in the offices. We have improved the quality of the air by 93%. As per the VDF systems, we have achieved 24% of the room temperature constant, and there are CO2 sensors that enhances the quality of the air. The spaces can also be naturally ventilated, and the facade creates a difference between the degree Celsius, and we are achieving 27 degrees Celsius in the interior spaces. All the spaces and offices are aligned as per the comfort ASHRAE standard comfort 55. As per the WWR30, an indirect light entering the spaces, we have calculated that we are achieving 63% of the daylight, which will be naturally. We are giving 34% of views for the users that will allow them to connect indoors and outdoors. We have further tried to reduce down the glare by 4% in the building to enhance the visual quality for the users.
Water, the essence of life, is a cornerstone of our commitment to sustainability within our building. Through strategic water management and effective utilization, we've ensured effective utilization and consumption. Our project aims towards minimizing water consumption by using effective fixtures, drip irrigation systems, and drought-tolerant species, maximizing alternate water generation through rainwater harvesting systems, and reusing grey and black water. By embracing a suite of effective fixtures ranging from low-flow faucets to dual-flush toilets, we've significantly curtailed our annual water usage. Thanks to adoption of green building approved fixtures, we've achieved an astounding 54% of reduction, bringing down our annual water consumption from 4 crore 76 lakhs to 1 crore 78 lakh litre per year. Yet, our commitment to water sustainability extends beyond mere reduction. We've also embraced a potential of alternate water source, notably through rainwater harvesting system, yielding a substantial of 1 crore 23 lakh litre per year, stored in primary tank, which is capable of holding 1.5 days of water. Furthermore, we've also harnessed a potential of grey and black water, repurposing these streams through advanced treatment systems. With an efficient MBBR and an after-storage period of 1.5 days, this treated wastewater finds new life into irrigation systems, chiller systems, and even flushings. With a total yearly demand of 2 crore 69 lakhs and an on-site water generation of 2 crore 66 lakhs, we find ourselves requesting only 3 lakhs of water from municipal corporation, which means we are asking for only 2% of water. In essence, to water conservation, our project embodies responsibility, efficiency, and innovation. By implementing these strategies, we are 98% on our way to becoming a net zero water building.
Consider that we are in seismic zone 3, we use 2 expansion joints, dividing our building into 3 zones. Further, with the help of the wind side brochure provided to us, we have got wind turbines working at 0 decibels up to 2 meters, whereas with 20 rotations per minute. They have also provided us with details connecting the wind turbines with our post-tension slabs. We have basement and building which are structurally integrated with each other, and we have green RG spaces on the earth of 25%. Structural diagrams and load diagrams were generated with the help of E-tabs to understand the structural integrity of the building.
For resilience, we begin by identifying potential risks that confronts the site, such as flood, monsoon waterlogging, earthquake type 3. But the critical risk still remains the unarcing threat of climate change. Climate change represents a critical and imminent threat to Mumbai's present-day landscape. It does not just affect inhabitants, but also environment. This graph suggests that by 2050, Mumbai could experience an increase in sea level and heat waves. Here's an approach designed to address risk and climate change in the face of natural disaster, climate change, and social and economic upheavals. To protect, which means anticipating proactive measures; to avoid, which means strengthening the structure or minimizing the exposure; to accommodate, which means adaptive coping. To ensure the safety of building and occupants during flood and monsoon, we have implemented bioretention swales, which not just helps in stormwater infiltration, but also helps in conveyance of the structure. Plinth levels are elevated by 1.2 meters to prevent the water entering into the building. For seismic resilience, we have provided with expansion joint after 20 meters to avoid the expansion and contraction of the material due to temperature changes. For fire norms as per DCPR has been well equipped into our building. Awning windows are provided after every regular interval to help in smoke disposal during fire. In case of reoccurrence of pandemic, our office spaces are well equipped with sources that can convert it into relief camps. Under solid waste management, we've also provided with proper treatment, segregation, and recycling. And recycling is to the extent of even recycling sanitary napkins, which makes our project zero waste generation in real sense.
In embodied carbon, we have done a critical evaluation of all the materials, where we have chosen two basic principles of maximizing the recycled material use and minimal distance from the manufacturing site. All of this following approach helps us in roof, fenestration, structural, gives us astounding reduction of 62% in carbon footprint. Let's dive deeper into the project. Kohinoor is a part of a Mahim redevelopment project, where 15 cubic ton of demolition debris are going to be formed. These demolition debris usually end up into the landfills. To negate that, we are setting up a 2,000 square feet of a site on the northwest of our site to produce K-bricks. K-bricks, when stacked with traditional materials, gives a U value of 0.22. But when stacked with Insuboard, which is a lightweight, non-toxic, fire-retardant material with a remarkably low carbon footprint, gives a U value of 0.13, which helps us to reduce the overall carbon emission. In affordability, with only 4% higher initial investment, we get a payback within 7 years with 300% higher initial life, with 300% higher life cycle cost return within 25 years. We have considered three cases. First is the conventional case, second is the energy efficient case, and third is the net zero case, where the window to wall ratio is 30%, the overall reduction is 40%, and we are generating a surplus of green renewable energy. This is the comparative analysis. So when we consider the baseline, we are getting a payback of 14 year within 14 years and the returns of 720 crores. When we consider 11 years of a payback, we get a return of 1,000 crores. But when you invest in Kohinoor Edge, we get a return within 7 years and with the returns of 2,000 crores. If you ask why choose us, we have an enhanced building envelope along with giving occupants the thermal comfort with optimized HVAC system and technologies and generating surplus of green renewable energy. In value proposition, Kohinoor Edge is placed in the Mahim's one of the most prime locations where the accessibility is easy and we promise the business will definitely flourish. Providing with modern amenities from IoT-based systems to top-notch HVAC systems, you ask it, we have it. We are setting up a benchmark for high-rise systems where we are reducing 49% of EPI, 54% of reduced water consumption, 62% of reduced embodied carbon, and 300% higher life cycle cost returns. At Kohinoor Edge, we want to give a work-life balance where one with working can also rejuvenate at the clubhouse and then at the library, socialize at the kiosk and the amphitheater, along with flourishing their business at the amphitheater. If you ask what is in it for the client, with only 4% higher initial investment, we get a return of 300%, which is the life cycle cost return. All of this circles back to this core concept of synergyscape. If you ask what is synergyscape, here we are bringing a platter for all of the people. This building is just not for the occupants, but it is for the community, where the community can come in, bring in all of the joy that can make this building more of a presence. We have also checked the IGBC Green New Building rated system, where we are achieving 83 points, and we are probable platinum rated building. I would like to end with a quote: investment to protect air and water, wilderness and wildlife is indeed the investment to protect the humanity. Thank you. We would like to show a demo of a prototype.
Where we are planning to have a connect with the nature, where plants will be there and the people will be working in this space, and they'll have direct contact with the green plantations that will further enhance their health, as well as it will increase the air quality in the room. Yeah, this is what we are proposing. And also the recycled, the drinking water is also will be the wastage of the
Your time is up.
Yeah,
thank you.
Yeah, thank you.
Good job, team. Well on time and also great presentation. We'll move to the jurors and take their comments. This time I'd like to start with Dheeraj. Yeah.
Nice presentation, nice command on the subject. Not to take away the credit of all of you, but the lady in the end who was given the task of completing within the time, I appreciate her because she modulated it well. One question which I asked in my report, not a question, rather a suggestion which I had said, please focus on that. I'm again saying that good work done. You spoke about air conditioning efficiency at 6.17, linking it to the ECBC 2017 standards. Today, the equipment levels efficiencies have reached a level which is much higher than this. It is at least 15 to 20% higher efficiency equipments available. So whatever you are achieving on an EPI level, you could have done much better had you chosen equipments which is higher on efficiency and also implemented it. Other than that, my observation is overall, I think you have been able to do a good job from bringing down the task given to you in terms of whether it is water related, energy related, equipment selection, looking at passive strategies. It's an overall good job. So no questions further from my side.
Thank you. Thank you so much, sir.
I think Kohinoor is going to appoint you as a marketing head or something like that. So for a moment I felt that are you from the marketing team? But good presentation, and as he mentioned that all of you were in a good flow and you had rehearsed very well, a lot of numbers. I think I have to go to a question that as a student, what was a takeaway through this exercise when we are designing from the urban context? So yeah, it's a need for a today. And what was a takeaway for all four of you? And what was a part where you really felt that, yes, I have done this? So what would you like to say individually, quickly, everyone will know.
So I understood that we need to be very, very sensitive towards the nature and try to incorporate the resources which are there around us and make the building more as much efficient as we can. Yeah.
As you said that we have been a part of this building entirely. This has been a 9-month baby for us. So putting in each and every, looking at each and every nitty-gritty, starting from the site analysis, as we mentioned that it is a redevelopment project. You can't actually gauge the scale what you are going to build over there because there's existing buildings over there. But by brainstorming about it and looking back to everything that we have done, I think today is a great day.
So I think what we've learned is that every part of that contest which were prepared should be taken care of in like
in every ways possible, like being sensitive towards nature. So what I felt was that we were doing multiple contests, but in the end it came together. Like I explained energy, so I would take an example of that. In case of energy, we thought that design was completely different from what energy is. But when we look all over, our shading devices, our green screens, right from the walls that we are using, everything helps in energy HVAC to reduce the energy consumption. So that was a major learning from, like, everything comes together in the end.
Yeah, Sumit, over to you.
Yeah, can you just go back to the slide where you had the green screen? I think one of them, I think one of the initial slides. Oh, it was a beautiful slide with the solar PV and this.
This one, the cover page.
Yeah, just go back. Yeah, this. Where you had the solar PV and the green screen on top of it. Yeah, maybe just go back a couple of slides back. I think that is enough for us to. Yeah. So you have this green screen beautifully. I think you've done the calculations behind the solar PV as well. How do you water these plants?
So watering this plant will be done by irrigation systems
Yeah.
that will be reusing the water, and there will be a pipe.
So
Drip.
how will you install the irrigation system? How will you go there and do it?
So there will be these small pipes that will be added onto the facade, and the maintenance will be purely done from the outside.
How will you do it?
From the terrace itself.
Yeah. So I mean, see, this will prevent you from doing it because the facade is such, right? It's like this, right? It will prevent you from doing it. So the point is not, I'm not trying to point out an error. What I'm saying is when you look at these ideas, and I really want you to think of these ideas, think it through. Think like the person who's going to maintain this. A lot of effort goes to pull this off. It's good to show it in a report. I'm sure these numbers will all be there. The thinking through is what is necessary, because you're all going to go into practice after a period of time. You're going to be designing buildings. The attitude to think it through is what I'm looking for, and I wanted to sort of encourage all of you to look at that. You also spoke about paved-in tiles. I didn't see it anywhere other than the one sentence which you said in the entire report. Where is, you should also used it to set off a large part of your energy, but where is the paved-in in any of this building?
So paved tiles are strategically located near the lobby. The maximum people would come near the lobby. So we have only the part from here after the canopy to here.
Yeah, it's not marked anywhere in this. Okay, maybe it's all right. So how did you calculate energy coming out of the paved tiles? There's a lot of energy generation shown on the paved. I'm very, very surprised to see that. That's why. I mean, people would have been jumping at paved generating more energy if that was true. So
yeah, so one slide. So here we have located the paved tiles.
I missed it. All right.
Yeah. So our paved tiles generate 5 watts per step we are taking. So if we consider that a stride of a person is 0.8 and the distance that the distance that the person is covering is around. So if the distance is covered by 42 meters by the person, and with a 0.8 stride, we have 75 steps coming and going twice in the morning and the evening. So we take 150, and we have around 3,000 employees. Let's consider 75% of it. That gives us 2,500 people. So around 3 lakhs steps per day. So these 3 lakh steps per day into 5 watts gives gives us 1,880 kilowatt hour per day. And this into 296 days of working days gives us 5,55,000.
I mean, if this is true, people would be installing this everywhere, I'm sure. Is this estimated in your sort of cost estimate? PaveGen, the cost of it you have. So anyway, so thanks a lot for your effort. There are a lot of ideas here. I mean, the only thing I would just encourage all of you to do is like take it through to the end of it. Don't just take it at the idea itself. Do the engineering behind it. Do the integration with the architecture. The PaveGen is a hatch here, but the effort is a lot more than just the hatch here. Anyway, wonderful effort. Thank you for your time. Thank you. Thank you.
Yeah, thank you, jury members. Thank you, Team Unix.
Monish, I'll take 10 seconds, okay?
Okay, we have time.
Just
Yeah,
10 seconds only.
Yeah, sure.
I like the connect you have established with the project, all of you, and I wanted to appreciate this at the end of it. Make sure in your life, whatever you do, this kind of a connect with everything, whatever you do, must be there. That helps you in succeeding in whatever you do.
Thank you. Thank you. Thank you, Dheeraj. So for our next presentation, let's take a 5-minute time to set up. One thing I like to tell every presenters and even the jury members is to hold your mic close. Okay, yeah. So for our fourth presentation, we have Team Sristi. They have worked on Project Karma in Bejai, Mangaluru. Yeah, teams, you can come up on the stage. Yeah, open your presentation.
Good afternoon, panel. We are Team Sristi, and I am Chiran,
wait.
the team lead.
Yeah, your time starts now.
Good afternoon, panel. I'm Chiran. I'm the team lead, fourth year BArch student. I'll be your presenter, and these are my co-presenters. Moving on, I'd like to introduce you to my team. Basically, a diverse group of architects and civil engineers and interior design from multiple years, so that we get a creative blend. Our approach. Our approach basically is an acronym of our name, Sristi, which is basically sustainability, robust, innovation, synergy, holistic, technological, and inspirational design. So moving ahead to the next slide, I would like to show you our faculty guides who have helped us throughout this journey, and our lead institution, that is Manipal School of Architecture and Planning. They have given us immense support throughout our project. So coming to our project, what was our idea selecting this project? So basically we see that nowadays big scale Indian projects are moving towards sustainability and trying to incorporate in large scales. But what about public government office spaces? What are the state of that? Still same, old, stagnant, not that well designed, and not sustainable at all. So to create an impact in this sector, we collaborated with Karnataka State Road Transport Corporation in association with Mangaluru Smart City. So the project summary.
So our project is basically Karma, which is located in BJ Lalbagh Road in Mangaluru, and all the site details have been mentioned here. So we initially started this project by by attending a lot of client discussions, and the client requirements were double the number of bus platforms from existing, incorporating more commercial spaces, increasing the office capacity, basement parking, and conventional hall for Ganesh Chaturthi and other activities. As well as we had to maintain all these present spaces and achieve it with a sustainable approach. So these are the site details. And after all this, we have come up with the user profile and spatial arrangement with the help of a flow chart. And this is the area programming that we have come up with.
Okay, so coming to climate analysis, the first factor that we'll be looking at is basically the psychometric chart. What we learned from this is the comfort situations that we're trying to focus around our design. So factors where a range of temperature in which we should focus, try to optimize the building around. Then we have the windrows and also the system that we use to design our shading devices. It tells us appropriate angles and sizes and dimensions for them so that most efficiently we can design our building. So here we have the sun path diagram and also the temperatures during the various months. So this gives us a set point temperature when it comes to energy optimization, and sun path helps us with the orientation of the building. Please,
yeah, these are some of the pictures of the present KSRTC bus stand when we went for the site study. So we modeled the same building and a central bus station from Thiruvananthapuram. And what we learned basically was how to integrate commercial spaces with office spaces, while also learning how to create privacy through the help of zoning.
Moving on to architectural design. So just to say what Karma means. So Karma is basically Karnataka State Road Administrative Office, Mangaluru. Basically it does just mean that. So from the case study and all the site study, we have understood that while integrating, this was our proposed KSRTC bus terminal, basically render and the floor plan. We'll get to know the detail of it as we go forward. So coming to our design process, what was it? So basically, as we said in the site study, we basically we noted down all the key points, like the locations which we had to take into consideration while going into the design process. So basically one of the major one was this is the junction where the bus can enter due to divider and all the other complications, and it is at a higher level. So it is almost 4,500 4,500 higher than the site area if you flatten it. So we had to take that into consideration. So going ahead, according to the client requirement and all the other factors, we divided the overall site into main building zone, the bus parking terminal area, and the bus entry area, which we intended to use as the secondary terminal area. So going ahead, we placed the road and saw how does it work and analyzed which areas could be used for what. So here in this area, we thought it would be a perfect area for bus terminal 2, which could take interstate buses. So they are not going to stay for longer in the area. So they can just come here, park, and just turn around and go back. So that was a major idea. Then we analyzed the massing. According to the area programming, we did a massing which was east-west oriented, so according to ECBC suggestion. Going ahead to make sure that the shading is also there on the terminal 2, we basically had a stretch of building on top of it also, which could be also used as a separate zoning for a residential area, since we had three type of spaces in our building. So as we saw in climate study, the most major way we had heat gain or temperature increase was due to solar radiation. So to cope up with that, our strategy was push and pull strategy, where we created shading within the building to help us to reduce solar heat gain. So this was the final thing we came up without the road. So this is the terminal 1 below the road. Basically, it's like a flyover going above and there's a bus stand below it, which is completely semi-open so that it allows free wind flow throughout. According to wind direction also, it is towards the west, and we have placed the guest houses in that area so it gets good ventilation, and the office spaces here. So I'll explain it through, this is the final render we have. So going ahead of the service placements, so we can see here that circulation is on the two cores. For different areas, there are separate circulation lines. In the next diagram, we can see the washroom placements, and in the final diagram, we can see the AH unit. So each consideration was basically so that the services could be dealt easily, and there was not much confusions in it. So as I said, we tried to zone separately. So we wanted to keep each zone separately according to our case study. So the office zone has a separate entry, separate washroom, and there are no connection between the commercial and office area because it was an exclusive office for KSRTC. And here we have the Yatri Nivas. The user profiles are also different. So they have a separate entry and they're far from the office spaces because it is someone visitors coming. And here we have the commercial area where we have the multiplex and small shop, like some shop where a retail shop could come up. Sorry, one more thing here was the exploded view, where we can see the overall how the building works in heights, because there's a lot of change of heights happening in the building. Then all the strategies mentioned here, which will deal in health and well-being, go in detail of that. So basically, this is the exploded view. So this is a section showing the workability of the solar chimney what we have, which I'll explain in further slides, and how the flows work. Like there's a convention hall, then the multiplex, and how the office spaces are divided, and the terminal space where we have mushroom columns and all, which makes the building more aesthetically pleasing and open, large scale, welcoming also. Yeah, this was the last slide for our architecture. This was a render of the reception. And finally, the last slide where shows the simulations proving all our designs and helping us. So basically, this is without the courtyard, and after the courtyard, how the lighting has improved within the building. And the initial energy simulation we did on Revit for the design. Moving forward to energy and operations.
Okay, so coming to energy and operation, first thing that we focused was the column layout, because any building structural element is very important. So we focused on that. So as part of that, we ran load and bending moment simulations on StatPro. Based on that, we cross-checked our placements, and we have come up with this layout. Similarly, we also ran structural analysis on the Terminal 2 bridge also. Yeah, that's this. And okay, so in our design, we incorporated waffle slab, because in a bus station, what is significantly required is a large open spaces. For that, we had to incorporate waffle slab system, and here we have given the specification in terms of the beam and the column structurally. So, okay, coming to HVAC system, like Chiran previously mentioned, we are not having active cooling in the entire building. Only areas that are required are actively cooled. So here we have separated those areas and shown which are actively cooled and which are not. And then we calculated the BTU on the different floors. Yeah, so that's that. In terms of lighting, we have lighting that changes from cool to warm, so that can match with the circadian rhythm, which is good for people in terms of health and well-being. And the building management system, different elements have been considered in the design, and building management system is so critical that it brings the whole thing together as a whole. So having that is a critical part of the design. Innovation.
Yeah. We've tried to use innovation to enhance the productivity of our building. For example, piezoelectric flooring, it converts kinetic energy into electrical energy. So we've incorporated them in high traffic zones like the entry areas of the bus terminal and the ticket collection areas. And smart grid system, smart city is something that is incorporated in a country level, but we have taken that idea and incorporated in a building level because we have different kinds of energies that we are producing. So, and it is a 24/7 operational building, so we can prioritize what kind of energy we want at what time. Yeah, demand control ventilation. Basically, the sensor sends the signal to the BMS system, which sends it to the HVAC system, which then controls the comfort of the zone. So, demand control and the urban farming, we've both borrowed the whole setup from research papers. And the main aim of the urban farming setup was for community engagement, which was lacking on our side. So, we could organize workshops, training sessions on site.
In health and well-being, we considered multiple health considerations like physical, mental, and social well-being was the main consideration. And first, we started by understanding what are considered healthy for a human being. So according to that, we had multiple passive strategies throughout the building. So I'll try to explain the whole thing with using this section. So it shows the double screen facade for temperature control, vertical gardens, which is an activity zone also, and gives a better view for the building and increases mental condition also. Solar chimney, which increases Venturi effect, funnel effect in the building, and also gives light by incorporating glazing on north side, and a courtyard or an atrium. And this is the overall well and health being according to design strategy wise, and an explanation for that. Going forward, we did simulations to understand how they work, and is it under the overall consideration of comfort zones, is it comfortable or not. And finally, in interior design wise, we considered landscape color psychology so that it is pleasing for mental, since it's a workspace, people have to work there. So we considered what type of plants can be used. And finally, the lighting, as we explained, lighting, what type of lighting we are using, and even the furniture, we have taken that into consideration. Going forward to energy performance.
Okay, so in terms of energy performance, two major factors that we had to consider was the wall assembly and also the fenestration assembly. So in terms of the wall assembly, we have first we have agrocrete with an air gap for insulation and also the terracotta jali. This combination gave us significant improvements in terms of the EPI values. And in terms of the window assembly, we have triple glazing with argon fill gas between them. These two things were something that contributed significantly towards how much the total EPI of the building came down. So yeah, here we have the outputs that we got from the analysis in the design builder. These are different factors that we focused on. Our designing process in terms of the whole project was that different aspects of the building we analyzed, and we went through the different options that's possible to give us something that is the lowest EPI, but while not ruining the architectural element of it. So balancing both is how we came up with the design. In our initial values, just through HVAC system, including HVAC system and all other material optimization, we got an EPI of 65, which actually further reduces up to 44 when we incorporate the solar generation. And further, for our piezoelectric system, we get an EPI up to 8.7. So yeah, that's in terms of that. With respect to HVAC system, we are going for an VRF air-cooled system. And here we have showcased how the different elements have contributed to the performance.
Starting with the water performance, that is water usage and consumption. So we have made use of strategies like aerators, sensor timings for taps, dual flushing system, as well as low flow fixtures, by which we have reduced the entire water consumption up to half from the base case. So coming to the water balance by calculation, we have basically calculated the total effective catchment area on the site. Our main aim was to be independent of municipal water supply. So that has been tackled by implementing rainwater harvesting system on the site. And the graphs mentioned on the other side, basically they have been derived from the table of monthly water collection that has been done for over a period of 1 year. Okay, coming to water treatment systems, we have bioswale as well as STP. So we have partnered with Akam Eco, which has an efficiency of 80% and has a lifespan of more than 50 years, along with noise production less than 50 decibels. Summarizing the entire water circulation, so our main source of water is rainwater. So we basically have 3 tanks. The fire water tank, which has a capacity of 2.5 lakh liters, is used only during fire emergencies, whereas the main storage tank, which has a capacity of 1.5 lakh liters, which is used for domestic purposes like cleaning, washing, and drinking, after being used, gets into the bioswale and or on-site STP, which after treatment gets into the treated recycled water storage, which can be further used in activities like flushing and irrigation. So from the water efficiency formula, we are showing that we are water positive. Coming to embodied carbon.
So as part of embodied carbon, there are 2 factors that are critical. First, the material. Second, how you acquire that material. So in terms of material, we went with agrocrete, which is a carbon positive material, and also we went with GGBS concrete. Now, GGBS concrete is incorporated in the structural elements, while agrocrete in the walls. So it reduces up to 91% with agrocrete and up to 55% with GGBS. In terms of the material acquisition, we went through different partners that we could acquire and optimize it such that partners who could provide us close in terms of location that's closest to our site helped us reduce the carbon footprint, because that's something people tend to look about when they just try to pick up what is the most carbon negative material. So in terms of the location also is something that should be kept in mind when you pick materials. Resilient.
To make the building more resilient, as you can see here that Mangalore it has one of the highest flood frequencies in Karnataka. So to tackle that, we have grasscrete and bioswale on the site. And to reduce the heat island effect due to the decrease in green cover, we have vertical gardens, especially on facades like glass facade. And Mangalore has a lot of particulate matter in its air. So for that, like we mentioned before, we have the low emission HVAC system and the demand control ventilation, which helps with the indoor air quality. And like my friends mentioned about low flow toilets and structural resilience through waffle slabs.
Finally, moving on to affordability. So when we talk about government projects, they mostly focus on affordability of the building. So this was the initial, this is the cost of project summary overall, and if you compare the base case and our case, it's slightly higher. So basically we need higher capex. But when we consider the OPEX and the operational cost as we go front, we see that we are actually saving money in the overall life cycle. So this is achieved through cost reduction by finance, management, materials, and the energy things what we have already mentioned. So they basically reduce our OPEX and also CAPEX in some regions and helping us to achieve this saving model. So this is the life cycle analysis which is put here and how it helps us to reduce overall life cost, how it is lower than the base case. And this is the graph showing the same. So overall. Moving forward to value proposition. So what value does this add to our project partner? So basically, when the highlights are, it's highly energy efficient building, high water performance, higher air quality index, on-site energy production, lower energy consumption, and reduced construction time and cost due to implementation of waffle slab. So basically, our construction, if you had to go to grid system without waffle slab, it would take a lot more time, and basically use of materials and construction technique. So basically, overall, when we summarize the GRIA criteria, we are in these each 10 categories, we are ticking on to a lot of stuffs, and basically our building is almost near to rating of 4 to 5. It has potential to get so much rating. And as you all know that public office spaces give a lot of impact on society in terms of sustainability and all. But a bus terminal being a sustainability with it basically integrates the sustainability into the lives of common man or a general public, gets them to experience it, basically bringing a change in people's life to move towards sustainability, basically making India's journey towards net zero country more stronger and faster. And we see scalability in this project because there are bus stands, bus terminals in each tier 2, tier 3 cities, wherever we see. Like some projects are
Thank
very
you,
tier
team.
1.
The time is up. Yeah, so we'll move on to the jury comments and questions. I think, yeah, I'll set the timer. Anuja, you can start. Yeah.
Okay. Team Sristi, good presentation. Only you could have a little bit more crisper in your presentation. So you had a lot of things to explain, but you had got a little less time. No problem. And you could have added more 3D views. That's what I felt, that when you had simulated so many of them, you should have added. My question to you, I was little skeptical about that top jali on top of your courtyard.
So basically the jali work, to answer about it, it's a skylight jali work. So basically it has a glass covering. On that we have terracotta to not make the glass gain more heat, to absorb the heat and give interesting lighting scenarios within the building.
Okay, but that was something which was not very clear in your presentation, and that's why, you know, I kept on seeing that, and that was something miss you could have explained. And I really felt that you had site was a challenge, you mitigated it quite well, but when you're dealing with the section, though you presented here, but still it was not clear that there is a glass on the top.
Yes.
And you have it constantly looked like there is only jali. And that kept us worrying us that
rain,
how rain and the maintenance, you know, typically when you're designing for the government organization, whatever you're proposing, you have to make sure that it doesn't become a white elephant for them. Yes. So that's where it is very important for us to look at what we are proposing for them. So actually my question to you, that if I have to consider this module for any of the Indian such situations, so what could be the element, what you really feel that from the Indian climatic context, you would change from your design? A quick answer would do.
For different climates, basically, right? Yeah. So in Mangalore, the only challenge was it's a warm and humid climate. So we couldn't integrate anything with water. So because it would increase the humidity of the place. So if at all it was in other places, we would have facades, like if at all water, it's like water, what do we say, cooling effect for water could be used. We would use jalis or the double facade which would have flowing water within them with terracotta. First change. Second change would be the one more constraint we had in this project was the site. So basically in the front it was narrow and the back it was wider. But the bus terminal had to be in the back because it had a depot space behind us. So because of that, the site constraint, we had to stick to an L shape. But if at all there was a flexibility, I would suggest the bus terminal should be more of a semicircular one. Because in our case study, when we compared Thiruvananthapuram and the present one here, the semicircular one was much more efficient in taking the consideration waiting spaces. Like when you enter, you can see all the platforms. In a L shape, you have to move a lot to find the platform. So in perspective of a traveler, the C shape, and in terms of office, we can have semicircular space in the northern facade and give more lighting.
When you look at the noise or the acoustics, because there are so many buses coming, they are going to honk. What considerations you have taken from that perspective?
The reason for that, we have started the bus or the KSRTC office after 2 levels. and the basement levels are double heighted. So but not the basement, right? Sorry, LGF and UGF are double heighted. So basically the building is a higher level, and we have that push and pull and the double skin facade. So basically we have tried to, and plantings, basically we have plantings on the push, wherever we have large corridors, we have vertical gardens there. And above that, wherever double skin facade is there, we have a air gap in between and the basically micro gaps. Because of that, the amount of noise coming is reduced. But at the end of the moment, we have tried, like it has to be in the bus stand. We can't change the location, but we have tried through our design to minimize it.
Happy to see the challenge you have accepted to get into a government building, and that to an application which is very different. This gives a lot of encouragement to others also, I believe so. Did not see, in case I missed, I'm sorry, but did not see, did you consider applying it for any of the IGBC certifications or something like that?
We, in the end, we have GRIA criteria we have tried to.
That's what I said, I probably have missed it. So, where do you think you stand today when you look at GRIA?
GRIA criteria, we did a consideration, we went to their books and tried to note how much points we get. So according to that, we have a potential to reach 4 to 5 stars.
4 to 5 stars.
Yes.
That's very good. Thank you. That's all from my side.
Yeah, Samit.
Thank you for a wonderful presentation. You've sequenced it right. There's this beautiful image about the chimney. Of course, I also have. I saw a green vertical garden. I'm very scared of vertical gardens. They're too on the outside. I'm petrified trying to think of how I'm going to water that. But I'll not ask a question on the garden, but the chimney, I think there was this image.
Solar chimney, yes.
Yeah. So the chimney, it's a vital part of your design, right? I mean, you're trying to pull off an office space in Mangalore, which is very, very humid, and usually very hot, extremely uncomfortable, and you're trying to push to present to your project partner a space which is going to be not entirely air conditioned, right? Only some spaces. So how did you design the chimney?
So basically, the main problem was lighting. As I showed in the previous simulation, it was very dark inside, but we couldn't make the building linear.
Right.
So that time our idea was to incorporate courtyard.
Yeah.
But Mangalore has a heavy torrential rain, and giving a courtyard will make it messy because we can't take the courtyard throughout because of the terminal.
Right.
So that time our first choice was to atrium, but atrium will have glass, again increasing heat. So we had to make this problem our positive. So the best option we had was solar chimney. But one more problem was solar chimney, some places it doesn't give light. So we gave this arc and a glazing facade on the northern side so that there is light which we require and heating which will give that funnel effect and eventually effect to give the overall cooling. And in each floors, I didn't mention, near the double facade, we have one place where there is, according to the wind direction, we have an opening. So that there is a tunnel for the wind to come in.
So so if I'm the project partner and I want to sit in this office, how are you going to convince me this is going to be comfortable? Okay, the idea is good. There's a nice sketch on top of it. How do I sort of get the confidence it's going to be comfortable?
So before coming to the presentation, I went to the client, basically that letter is from there. I presented it to them. So he was very curious about this. How does it work? So I showed some studies, researches and all. Like basically they are not from architecture field. For them, this is something new. It's basically basically a more of account and EC's account more of less or like administration. So when I showed researches and all that, it shows effect even in climates where heating, even in AC, it's not so comfortable, like research papers. He was like, okay, not completely convinced. He was like, wanted to see more renders or walkthroughs. So because he was more into aesthetic part, how it looked from down and stuffs and all.
Yeah.
So I showed him the walkthrough. So walkthrough link was there, but we were not allowed to show.
How can you convince him now? The walkthrough is fine, looks fine. How is it going to work? So,
okay, I understood your point. So I would, if I had to show him a practical example, I would use a bottle, for example, a bottle cap cut, and I would like make a mini model of it or something to show that how Venturi effect, which sounds so simple in their logic, but how efficient it is.
So you could also try simulation studies.
Yeah, that is there already.
Simulation to justify your design.
Yes.
So that's the important thing, right? The sketch and the idea, the bottle, all of that is good. If if it doesn't work,
Hmm.
they're going to, sort of push
Like
this
for
aside,
example, when I
right?
showed the simulation, he was just like, "Whoa, why so much lines? What do they mean?" He didn't had no interest in seeing the simulation in
Yeah,
his presentation.
we are interested, so don't skip the simulation part of it. We are really interested in it.
Yeah.
Of course, it's a chimney, so you have to worry about rain kiting into the chimney itself.
Yeah.
That I'm sure you would have thought about.
Hmm.
All right, thank you. Thank you for the presentation.
Thank you.
Thanks.
Thank you, team. Now we will take a long break for lunch, and we will start with presentation. after the lunch, but I think the presentations coming up next will help us get in track. Okay, so our fifth presentation is from team Under the Arc. They have worked on Project Raven infrastructure with an ambitious goal of achieving net positive. The project is situated in Fulanakhara, Kotak, Odisha. Okay, team, you can take the stage. Put it on presenter mode. Yeah. What's the name? Okay, team, ready? Your time starts now.
Good afternoon to all jury members present over here. We are the team Under the Arch, and we are going to present our project, Raven Infra Developer, which is an office building and which collaborates all the important and infrastructure development and people like architects, engineers, builders, and property dealers in the same place. Our project lies in Cuttack, Fulanakhara, Cuttack, Odisha, and our site is facing a climatic zone of hot and humid with an area of 2,830
Presenter,
square meters.
please hold the mic closer.
The site area which is provided to us was 2,830 square meters, and the building will be operable from 9 to 5 if the total ground coverage is 40% and permissible FAR was given to us was 2, and some important requirements of our project partner was building aesthetic, healthy workspace of our occupants, and green building to achieve green building parameters. Our building lies in Bhubaneswar-Cuttack highway, and there is no major building present over there. So our building has a front facade towards the west side, so we have to cope up with this solar radiation, solar glaze on western and eastern side of the facade. The maximum rainfall in a month is around 350 mm, and the annual cumulative horizontal solar radiation of 1821.4 watt-hour per meter square. Our site has a parallelogram shape with a ground coverage of 1132 meters square and a green area of
presenter, one second. Can you move a bit to the left? Yeah.
And the green area of 900 meters square. Our building plane is extruded to a height of 24.3 meter, and both a central part and 2 side part are extruded from the building for better light and ventilation in the interiors. Our vertical circulation in the building was established on both the ends of the building, and ETFE facade was implemented on western and eastern side to counter the solar glaze in interior spaces. 2.5 meter balcony was extruded for horizontal shading. This is our site plan, which elaborates the shape and geometry and building orientation of our building. The steel plan was dedicated to parking, and first floor was given to recreational areas like cafeteria, sitting, reception, green spaces, and library. And second floor, third floor, and fourth floor was dedicated to builder, property dealer, and architect. This is the section and exploded view of our building, which elaborates the horizontal and vertical zoning in building. Now coming to innovation, we have implemented ETFE non-concealed facade, which is a translucent polyethylene. ETFE stands for ethylene tetrafluoroethylene, which is a translucent facade and gives in a soothing environment in interior spaces. There is a cutout in our building which was devoted to green area and maximize the ventilation and passive cooling inside the building. And terrace gardening was a slab of semi-intensive green space was introduced in center. The staircase was not concealed, and it was given ventilators in every floors for horizontal and vertical ventilation in every floors.
Now coming on to engineering and operations, this is the foundation and column layout of our project, for which we have in column layout we have proposed two types of columns. For shorter span we have provided columns of 250 mm and 250 mm, and for longer side we have provided columns of 300 mm to 600 mm, and same for the footing, we have provided the footing of around 350 mm to 350 mm, and for the longer side we have provided 1800 into 2100 mm footings. We have done a complete structure analysis of our building using a software known as CAD Pro with the guidelines provided by IS 456. We have proposed a precast structural design, for which the structure of it is proposed that some of the structure is will be based from precast factories and other will be based on on-site construction. And the precast structures include slabs, doors and window modules, and walls. This is the electrical layout of the building. We have used top-notch 5-star fire-resistant wiring exceeding standard fire safety protocols for enhanced protection. This is the plumbing layout for the toilets, and as the building boasts a water-saving plumbing system meticulously designed to optimize efficiency through its entire cycle. The HVAC layout of the building, we have proposed a 20 TR VRF system, which is very precise, comfort, and has enhanced efficiency, flexible design, and is adaptable for the future. Now, coming on to the energy performance of the building, we have done envelope optimization using different iterations. The proposed iterations for wall assembly will we have proposed 215 mm brickwork, 200 mm rigid wool insulation with lime or polyester, in which we are able to achieve a U value of 0.18. For roof assemblies, we have proposed a 100 mm RCC slab with polyethylene spray of 30 mm, in which we have achieved a U value of 0.579. And for fenestration, we have proposed a double glazed vacuum window, and which we have U value of 0.76. For lighting load calculations, we are able to achieve a lighting load EPI of 5.056 kilowatt hour per square meter per year. We have done a proper calculation based system for each and every space of the building, and have done proper calculations regarding each and every lighting space of the building. We have also proposed a DALI system for our building. It is a fully automated operation system in which we can program and turn lights on and off based on the occupancy time of the day, and other criteria. For the next part, for the equipment and HVAC load calculations, we have done equipment load calculation according to the need of the equipment. We have proposed all 5-star equipments, and we have able to achieve an EPI of 2.75 kilowatt hour per meter square per year for equipment load. And for the HVAC load, we have proposed an EPI of 21.66 kilowatt hour per square meter per year. And total EPI we are able to achieve is 48.46 using these calculations. And for energy generation potential, our building is gets an average solar radiation of 5.5 kilowatt hour per square meter area and 300 clear sunny days every year, from which we are able to achieve the energy generation potential of 2,52,014 kilowatt hour per year, which is calculated using PV watt calculator by NREL. For health and well-being, we have made a table in which we show factors that affect health and well-being of a person in an office environment, which includes temperature, humidity, stagnant spaces, lighting, stuffiness, comfort and carbon dioxide levels. We have also proposed barrier-free building practices for the especially able people in the building. We have given provisions of HEPA filter, as it is one of the most efficient filters that can provide at least 99.9% airborne allergen pollutants, including mold spores, dust as small as 0.3 microns. And last is thermal comfort. As the site is placed in Cuttack, it is a very hot and humid climate, for which thermal comfort is very, very important. We have proposed an HVAC system of HVAC system. We have provided green spaces inside the building, and there is no one single room in the building which receives direct sunlight throughout the year. This is the main goal. Next.
So water performance, the portable requirement for building office building according to NBC is 45 LPCD. So we have reduced it around 42.2% of total initial demand, which is around 26 LPCD. So by installing low flow faucets and dual flushing toilets. The next is efficient plumbing fixtures are being added so that it will help to reduce the water consumption. So here is the water cycle diagram. So here we have initiated how we can treat the grey water so that we can reuse it by treating the water which are coming from the basins, sinks or the showers. We can reuse. We can treat that and reuse it for irrigation purposes or for non-portable resources. So now we have also, according to this, we have introduced rainwater harvesting system so that we can collect water from the roof and store in a tank and can utilize further by treating it. So we have introduced the root zone treatment. The root zone treatment is a natural way from which we can filter the water through gravels, sands, and also plants and microbes help to remove the pollutants from the water. So this is the root zone treatment plan, and it also have the benefit like we can also reduce the reliance upon the municipal water supply, and also it creates a sustainable site by as we are providing biofuels around the sites which store water and cut the runoff wastewater. Then we are coming to the embodied carbon. We have tried to decrease about 59.6% of the embodied carbon by introducing some construction methods like precast fabrication, precast construction instead of on-site construction, by reducing the extraordinary waste which creates carbon emissions. And next, we have introduced ETFE facade by not introducing the aluminum extruded profiles. Actually, aluminum extruded profiles are cannot be reused, but ETFE is a superior insulation facade which can retain solar radiation in the winters and repel in the summers. So now let's move on to resilience. As we know that the site is present in Cuttack, Odisha, and past 25 years it has introduced many kinds of natural calamities like floods, cyclones, and heat waves. So as we all know that Odisha is now advanced in weather prediction system, but we need to step up and work on the resilience of our buildings. So for this, we have for the solution here the building layout with a simple regular shape so that we can avoid the concentration of pressure with aerodynamic orientation, and also introduce cyclone resistant doors and windows which can withstand high winds. And also well-frame RCC construction is done in regard to cyclone. Next is heat waves. For the heat waves, we have introduced a natural ventilation system while designing a building, gave open space, and also insulation materials which has lower U values. The next are floods. So here in our design, the stilt or ground floor is dedicated to parking facilities. If worst case water, so that water doesn't reach to the main office building and damage it. Landscaping are provided on the site in form of bioswales, which helps in stormwater runoff. And proper drainage systems are provided in which stormwater drain from site is connected to that of municipal corporation. Some other resilience we have provided that are power outages. Power outages in an office can be a major problem. So we have installed solar power plant in the office. Passive design strategies has been taken into consideration. Next is fire breakout. Fire presents a significant risk to businesses. So by considering the norms of NBC, we have provided solutions like proper sprinkler and drencher systems around the building, and proper fire escape plans has been done in all the floors, and provision of fire lift and fire staircase have been provided, and a 6-meter wide road has been provided all around the building for the fire vehicle to revolve all around.
Moving on to affordability, we know that affordability is a main element in determining the design and construction of a building. In our case, we have achieved a total reduction of 21%. We have achieved it by using the following methods: use of lean construction techniques. Use of precast construction techniques had helped us in this. Precast construction techniques help us by producing less waste and are quicker than the conventional construction techniques. Use of locally sourced materials. All the materials that were used during the course of construction of that building can be sourced locally and are present within a radius of 150 kilometers from the site. And the majority of the building materials such as sand, brick and cement can be accessed from a local factory located 500 meters from the site itself. Additional operational costs have been reduced by using solar panels, advanced lighting sensors and passive cooling techniques. The capital expenditure, we have proposed the use of EPFE facade, which is 20% cheaper than the orthodox aluminum facades, and we have also proposed our project partner to use software like BIM, which can be used to optimize and reduce the overall capex of the construction. In case of operational expenditure, we have rainwater harvesting system and grey water treatment plants. We have also implemented the DALI system, which greatly reduces the electric consumption of a building. Value proposition. Our value proposition is divided into two parts: project partner based value proposition and user based value proposition. In the project partner based value proposition, we have the aesthetics. The aesthetics of the building would enable the project partner to lure new clients, which would help in its future ventures. We have given renewable energy sources which are commendable for a stronger community, as we have achieved an EPI of 48.46. In the user-based value proposition, we have provided barrier-free spaces, which mean that people having special disabilities can also access and freely use our buildings. We have provided recreational spaces, which would help in creating a better work environment for the users of that building. I would like to conclude our presentation with a brief conceptual walkthrough. This was team Under the Arch presenting before you. Thank you.
Thank you, team, for your presentation. Now let's head to the juries and listen their comments and questions. Yeah, Dheeraj, you can start.
A good, concise presentation. Thank you. My question relates to the forte in which I work. Somewhere in the report you mentioned that your area is about 700 square meters, I recollect. Is that right or wrong? 700 square meters.
That is of the landscaping.
Landscaping area.
Total site area is around 2,800 square meter.
2,800 square meters.
Yes.
So, how much of air conditioning load did you find out or figure out which you have installed over there?
So we have done load calculation based on that 400 square feet of the area would require 1 tier of the load, and that was how we had achieved 20 tier of HVAC load.
400 square feet per ton.
Yes, sir.
And how did you arrive at that?
So this was something which was taught to us in our HVAC classes in college.
I will request that do not go with any thumb rule impressions. You all are from an educated background. You got tools to do that. You need some data to do it. And that results into good and bad both. Infosys, the campus we are in, they also design at about 800 square feet a ton, 1000 square feet a ton, 600 square feet a ton. But that's what they do basis tools what they use. I will urge you to use tools, do not go with thumb impression. Another assumption which you have taken was 400 CFM per ton, right? And you have used an equipment called VRF system. VRF system consists of various types of indoor units. Not even 10% of the indoor units can give you 400 CFM a ton in VRF system. Not even 10% of indoor units. So now you can imagine how grossly the complete calculation can go wrong if you go with estimates or judgment. Okay, that's all I wanted to tell you because you are still in a state where you can learn a lot. Thank you.
Good afternoon. Even I have to tell you something rather than asking questions to you. One thing which I found that when you're working out on a footprint, for the architectural student especially, because there are engineers also part of the team. So architects, when you're working on the footprint, you have to create an efficient footprint. And if your plans are not efficient, I could see a lot of circulation space which is excess, and that is not required. So why are we building more? Once you start building precise to the requirement, and that's where it's very important that what is per person area you're considering, how you are using your NBC staircases. The staircases were very wide. There is no fire egress closure. They are all on exterior side. So, and then they were weird cut out into your plans. Now all that volume, you're conditioning, you're cleaning, you're flooring, for what? So you should create that kind of a footprint, which is very, very important once you start with the process. And then you will see the wonder that whole calculation analysis is going to give you good results. Second thing is that one confusion, probably I should call it as a confusion. You talked about prefab technology, but your structure, whatever slides you have shown, is not correlated with the prefab technology. So if there is any confusion about what structural system you're going for, because prefab, okay, you're developing something off-site, but the kind of a junctions it has, it needs to be mitigated, and the cost of those junctions evolving into those detail doesn't remain as a modular system. So again, the cost is involved into it. And even in the report, what you have submitted, there was a big confusion about which areas are in prefab and which are in the core shell. So your report was saying something and you're proposing something else. And right now, the same confusion, I could see it. So whatever you're proposing, you make sure that the engineering, I mean, that's what I just want to continue with Dheeraj, that there is so much of knowledge and so much of information is available. What suits to the choice what you're making is very important. So focus on that and study well yourself. You validate yourself and not copy paste the information, because there is a chances of failure. But when you do it yourself, you will not fail because you have learned it and earned it. Okay, good presentation.
Yeah, Sumit, over to you.
Thank you for the effort. 8-9 months or whatever time you spent on it, it's a lot of effort. I really appreciate that. Of course, I'm upset that you've taken 400 square feet per ton and not done simulation. There's so much of resources they've provided and all of that. But one thing, the ETFE facade, I'm still not clear. ETFE, you said, was translucent, and you said it's going to, you're trying to use it as a to reduce glare. But I'm not sure how that happens, because usually translucent layers tend to increase glare, and you're also trying to avoid the use of aluminium. I'm not even sure about that, because you still have a glass facade. Everything is there. So as of now, the way it looks like, the ETFE is another additional layer on top of a traditional layer. So how did it all end up in, reducing carbon? Because you've added another layer on top of it. Not very sort of clear. Can you explain that?
The main purpose of using ETFE facade, that the front facade was west facade, and the main thinking was that the ETFE will be translucent and the direct sun rays will not come inside the building. That was the main purpose.
Have you tried this ever? I mean, try this at home, just as advice. You try to have a translucent glass in front of you and try to use a light source behind and see how that works. My bet is that you will realize it's going to be worse than direct radiation. You can't see it. So anyway, you learn like this. So thank you very much for your effort. Good luck.
Thank you, sir.
Thank you.
Thank you, team under the arch. Let's take 5 minutes. I don't know how we went so fast, but we're here. Our sixth and final presentation is from Team Urban Carbon. They have worked on Project Infosys with innovative passive and active designs to meet the GRIHA and LEED standards. The project is based on indoor, and yeah, team, you can take the stage. Okay, just to brief you before, you will have 20 minutes to present your work to the jury. And at 15 minutes, I'll ring a bell like this, okay? You won't have a 21st minute, so be mindful. And which means at 20 minutes, I will stop you and ask you to end your presentation. So after that, we have the 10 minutes of Q&A, okay? Please keep your answers short and direct. Okay, team, the stage is yours. All the best. Your time starts now.
Good afternoon, jurors. We are Team Urban Carbon. We are a total of 6 students from second and third year of architecture and an engineering student. We would like to present to you our office building design proposal. Starting with the project partner, we had the opportunity to work with a multinational company of Infosys. They're currently setting up a campus in the Infosys Indore Super Corridor. It's a super corridor project where a lot of companies are setting up their campuses, which will host a lot of professionals in there. Coming to our project, the Infosys Indore Super Corridor project spread across 130 acres of land, which will host up to 5,000 software professionals. As per Infosys company guidelines, they are highly committed to GRIHA and LEED standards for all their buildings across the nation. Coming to on a campus level, we were supposed to design the SDB2, which is the software development block 2 over here. After doing thorough analysis on lot of levels, we concluded that direct evaporative cooling will work best in the composite climate in which we are present, and so it naturally became our primary strategy. Coming on to our site level, the overall site area was around 8,000 square meters with a maximum permissible build-up area of 36,000 square meters. We conducted a lot of analysis, which included sunpath analysis and identifying the summer and winter angles, which then affected the design decisions which were taken afterwards. Our design mostly revolved around 3 main aspects. The first one were the passive strategies, specifications from the project partner, and a basic requirement to design a net zero structure. All this was interlinked with social impact, climate responsive architecture, and finally a design which responds to the user base needs. All this was done while never compromising on the subject of aesthetics.
For the form development, we had the initial massing form divided into 3 parts, 3 blocks, which would have a floor plate depth of 20 meters each, and the distance between the 2 blocks would be 15 meters, so as to achieve maximum daylight during the daytime. Then we also cut off the solar sun radiations from the eastern and western facade. We had planned 6 cores on the corners of the building, and thus it would be helpful as the cores would absorb all the harmful solar radiations on the eastern and western facade. And the office floor plate was then planned between the both cores while having a central corridor in between. Then moving on to the ground floor, like we had a road going from all the 4 sides of the site. We had our entrance planned alongside to the entrance gate given, and then we had the drop off which led to the reception in the central wing. Then that reception has access to the C wing and the A wing in our building. We have the dining space, the reception, a dedicated daycare center for children, and also a banquet which could be rented in for commercial purposes. We also thought of having a fluid type of landscape in our design so as to contradict to the rigid form and structure of our building. Then the above floors, that are the first to 8 floors, were planned for the ODCs, that is the Offshore Development Center, and that's about the office floor.
After the ground floor was designed, all the floors up above were typically the same floor plate design with an open floor space area. As I had mentioned before, the passive down-out evaporative cooling was our primary strategy. So shafts were created from the central area in all the 3 buildings, and they were brought down to the ground floor. A mist chiller was given up on the above, and the cool air which will be coming down will be circulated across the floor plate by venting. The hot air will rise up from the shafts will be present on the edges of the core, and the pressure difference will be created to inlet and outlet sizing, and also by using the material which will increase the heat in the shafts which are present on the edges, so as to make the hot air rise up through the shafts present on the edges. Aesthetic choices which we made while designing the building were by referring the Infosys brand guidelines which were given, and a harmonious color palette was decided which had the contrasting blue of Infosys, so as to create a nice experience in the entire workspace. Our strategic window placement and cooling optimization was done so as to create a comfortable space.
For the structural design, we have designed a column grid which is 5.2 meters into 9 meters column grid, which help us to optimize the office floor spaces, and it also helps to structurally support the building layout. Coming up to the foundation part, the soil is identified as a black cotton soil, as this soil has a nature of highly expansions and highly compression. So here using a pile foundation was finalized. Coming up to the material, as the site lies in a composite climate, because of this composite climate, there are pretty harsh temperatures during the summers and winters. For this, the walling system was used as a sandwich wall system. For that, the outer layer were used as the AAC blocks and the inner layer was used as a cellulose insulation. It is made of waste paper. Now these are the details of the foundation and the materials. Coming up for the HVAC system, we are using a evaporative cooling system. It is a main primary concern for the HVAC system. Also, for the support, we are using a chiller, which is also based on the direct and indirect evaporative cooling, AHU, which is based on every floor, which helps to maintain the comfortable hours throughout the year. Coming up to the commissioning, we are proposing to start a green building commissioning from the pre-design phase of the building, and which ends to the post-occupancy phase of the building. For the water metering and energy audit is done after every 6 months after installing the systems for 24 months, and after every 3 years, we are checking these audits for the maintenance of the fixtures which used in the system. Are they good or not?
After understanding the work culture in IT offices and Infosys offices, we came across issues like long working hours, inflexible office setups, huge ODC teams, and maximum screen time. So to cater to these issues, we came up with a solution of integrating IoT with the concept of agile working stations. This feature helps with the customization and personalization of one's tables and seating arrangement as per their needs, ergonomics, team sizing of the ODC, and the location of each and every member of the team can be understood. Visitor management and scheduling also becomes easier. With the changing social conditions around us, we felt the need to having diversity in office setups, therefore providing gender-neutral toilets. These help promoting the inclusivity and diversity in office setups. Another issue faced with open floor plans that we've used is difficulty in finding quiet works areas and distractionless spaces. Therefore, we have proposed of giving focus workstations. These are made of advanced soundproofing with Millennium.
For achieving thermal comfort in our building, our first approach was to achieve thermal comfort to basic design only. So as mentioned before, in our design, the cores were placed on the eastern and western facade so as to cut off the harsh radiation, which will minimize the heat gain, and the longer facades were designed along the north and southern axis. For thermal comfort, we refer to the guidelines of IMAC, which is an Indian-based guidelines, which gave us a temperature range between 19.5 degrees Celsius to 26.43 degrees Celsius, which meant the building should have a temperature between this range so as to make the people in there comfortable. To achieve this, we identified strategies which should be implied in every month. As we know, Indore has a composite climate, so the temperatures were in the extremes. So our strategies differed from the summer months to the winter months drastically. For like summer months, our basic strategies were based on direct evaporative cooling and natural ventilation. Whereas for winter months, we were mostly focused on passive solar heating and internal heat gain. Simulations were conducted after conducting the how much hours have we done to achieve thermal comfort. We had 289 unmet hours, and after doing the data in form of PMV scale, we got a value of -0.46, through which we can conclude that 90% of people will be comfortable in the operative working hours of the office. In the well-being of the employees, there is an important aspect of inclusivity which is not quite addressed in office workspaces. For inclusivity, we had dedicated wheelchair support workstations, inclusion of gender-neutral toilets, presence of lifts, and emphasis on braille signages, installation of hearing loops and visual alarms as well. SDG 3, which is the Sustainable Development Goal 3 of UN, aims to ensure healthy lives and well-being for all ages, and we have tried to tackle this issue of not having an inclusive approach in the office spaces through this. In the energy performance, which is a very crucial aspect for designing a net zero building, like I told you before, the first approach was to reduce the loads as much as possible and then match it up with the renewable energy generation on site. This will ultimately lead us for creating a sustainable net zero energy building. For reducing load as much as possible, we had to optimize the efficient material palette for walling, roofing, and window. These assemblies needed to have U values as much as low as possible. For walling assembly, we had 0.22. For roofing assembly, it was 0.13. And for window assembly, it was 2.1 var per square meter per Kelvin. These standards were comparing with super ECBC standards. For the base case, we took the ECBC standards and tried to achieve super ECBC for the proposed U value systems. The lighting loads were the LPD, that is the lighting power density, was reduced from 9.5 to 5.0 through just efficient lighting fixtures. The EPR for building is finally 59.32 kilowatt per square meter per year, and the energy generation on site is around 24 lakhs kilowatt per year. So finally, we can conclude as generation is exceeding the consumption, our project is net positive in terms of energy performance. For energy generation, we are not only covering the solar rooftops, but also the parking adjacent to the building. The Sustainable Development Goal 7 aims to ensure access to reliable, sustainable energy for all.
Similar to water performance in terms of similar to energy performance in terms of water, we know that to achieve net zero, it becomes the primary strategy is to reduce the consumption. We have to cater to that, we have given efficient fixtures that have significantly reduced the water consumption from 41 liters per day to 21 liters per day. By doing so, we've achieved 68% in the water consumption reduction. Also by water balancing, monthly water balancing, which achieved 10 months of net zero with the help of rainwater and treatment of segregated black and grey water. The remaining 2 months we've been able to cater to net zero with the help of a pond in the campus and as well as treatment.
Moving to the embodied carbon emissions in our building, we have tried to achieve the initial base case for our embodied carbon per square meter was around 2500 kgs of CO2 equivalent, and then we, after trying different iterations in our building systems like the flooring, walling, roofing, and fenestrations, we had reduced and come up to approximately 1100 kgs of CO2 per square meter equivalent. And like for example, in the walling system, we had designed a wall which would have a sandwich of AAC blocks and cellulose insulation in between. The cellulose would be generated on from the paper we get from the site from the other office buildings in the campus, and thus we have a total of around 1500 kgs of CO2 reduction, which is approximately equal to 60 trees which can absorb CO2 annually, and thus a total of 57% of reduction from the base case has been achieved in carbon emissions.
Coming to the resilience factor, as it is an IT setup, a large number of devices are present in the office, so fire safety becomes a major concern. To cater to that, instead of providing water sprinklers, we have opted to have fire suppression systems based on heptafluoropropane. This helps with uh, uh, catering to the damage that can be caused with water while the time of fire. Moving forward, in terms of calamities, damage of flood can be avoided as the building is raised on stilts. These stilts can also be used as vaccination centers, and the banquet that we've had also as isolation wards. The plan for the same is proposed. Water and food storage for the same. Water storage for 2 days can be sufficed as in times of these days, and food for 3 days.
Then we had an open floor plan for our building which had minimum partition walls, and the building material was also finalized, which had a reduction in cost. But as we have many fixtures which are highly higher fixtures that consume less water or less energy, the operating cost, that is the OPEX, was reduced by 7%, but the capital expenditure, that is the CAPEX, was increased by 12%. And thus the initial cost, that was the initial cost per square meter, that was 40,000. It was then increased to 44,000 around per square meter. But even after increase in the cost, we had many tangible and intangible profits to it. Some of the intangible profits were like productivity in their work, then better work experience, and good employment retention rate in our office building.
Coming on to the value proposition, our proposed project also tries to specify the project partner's aspiration, but also tries to serve the end user's experience. Coming up to the construction of the building, we are proposing to build the construction in phases, which will try to help the client to generate early revenue. We are following every standards of GRIHA to design a comfortable space and using IMAC for comfort. We are now, because of following all the standards, we are trying to achieve a net zero building, which will ultimately help the user's productivity to increase, and it will ultimately help the client to grow.
After designing a sustainable net zero building, it will be only sensible enough to get it certified. So we are proposing to get it certified from an Indian-based certification system, which is of GRIHA. We are aiming for getting a 5-star certification from all the things that we have done, and which will come up with its own incentives, which will be good for the project partner and the client. Our project not only designs not only aims to design a building which will be good for productivity and the project partner, but we hope that it also serves as a beacon for the people and our companies which are to be set up in the future, and how office spaces can become an inspiration and can work as a sustainable spaces. Thank you.
Thank you, team. Finished well in time. Now let's hear from the juries. Sumit, we'll start with you. Yeah.
I have a lot of questions actually, but I'll limit myself to maybe 1 or 2 observations. Slide number 14 or 15, somewhere you had the roof assembly. You could go back to that. Yeah, the roofing assembly. So what's wrong with this assembly here? Do you think this is right, or there's something missing here?
So the 250 mm glass wool might be a little ambitious.
All right. Will this hold? There's no structural element here. It's just plasterboard, insulation.
The slab should also be mentioned.
Yeah. So that's a big error. And this is like a very, very fundamental thing. And I'm looking at this and I'm thinking that you missed out some basic. So get a little bit into the detail. This is actually very, very basic. You know, there's no structural element at all. You just missed it. Be a little careful about what you're presenting. I also saw, I think there was a suggestion on fire suppression. Very, very expensive to do it for a full office. I'm not sure if estimated that at all. People are scared of doing it for small areas because it's so expensive. It's just not going to work. So if you've taken, see, all these contests are meant to sort of round up your knowledge, you know. And if you're equally diligent in all of these contests, some of these ideas will go out of your presentation. You will not even present it to us. So that's the idea. So if you had done the affordability bit right, you would have figured that, no, that's not going to work. Right? So it's important to look at all of this. The contest gives you a very good template to work with all your lives, I'm telling you, not just to you, all the contestants. You have very, very nice template. Usually, a lot of professional organizations wouldn't also do it. Right? So use a template. These are sort of gaps which you would have yourself eliminated. I also saw evaporative cooling. How do you sort of, what is the sizing behind the evaporative cooling? I'm not going to get into the details. I didn't see those details in the report as well. How do you make sure this kind of an office is going to be comfortable with evaporative cooling? There's a lot of analysis which is required for you to be able to convince your project partner to do some of the ideas which you have in mind. So get into the detail. There's a wonderful template provided. If you do all of them diligently, and it's true in practice as well, not just as a student. If you do all of them diligently, I think you'll get a much more workable solution. Yeah. Thank you so much for the effort.
Yeah, Anuja.
Can you just go to a typical flow plate where you have core and the furniture layout? And that you present it only with reference to something. Yeah, just hold it there. So for any commercial footprint, the core to the usable footprint ratio is, if it's more than 15%, this core is huge. And second, the flouting with the NBC, how many steps you have in one? It's more than 13, so it's not allowed. So, and they are not allowed from, again, from the disaster perspective. It's from the calculation of the fire, egress calculation. So all these norms needs to be followed when you're planning. So if you're not planning that, you know, as I said, that it starts with your contest number 1, where you start with the floor plate efficiency. And if I don't see that efficiency coming here, the story doesn't begin ahead. So architectural team has to be extra careful when we are designing, when we are beginning, we are moving our pencil. So that's what I felt. And most of the contest, as he rightly said, you've just barely touched base. There is no analysis given to it. Why certain things? It is just the collation or the copy paste of course, there's a hard work. But what I found is that you have not attempted. It just remained as a thought. Ye karna hai. But that remained there. Otherwise, it could have turned into a wonderful design. But you have not reached. You are still at that stage. So there is so much. I mean, I can go on every slide. There are many things which are there, but design had a lot potential to evolve, to come to certain level. So many things are unresolved in the design right now, and which we didn't get a clarity when we went through. You all spoke well your parts, but still I felt that it is somewhere incomplete for us to register or have certain amount of impact. So you have to work towards it for your future presentation. There is a lot of hard work, but then it has to reach where it has to reach, right? So all the best.
Yeah, lastly, Dheeraj.
So both of them didn't ask any question. Let me ask question. Give me 3 ideas which this team was able to implement in the report and not given by the project partner as a guidance. What were the 3 things which you were able to put down in the report and happy about it?
So the Infosys primarily focused on radiant cooling, but we suggested upon the evaporative, passive downward evaporative cooling as the primary strategy. So that was one different thing. Also in the basic layout, the plan was raised up, elevated as a single block, but we suggested that it should be done north-south aligned and in 3 phases. That was another thing. And inclusion of landscape in an office building should be one aspect to create a better office spaces was one.
Thank you. I'm glad you are able to push that through. Thank you.
Sorry. Thank you, team. I think that's it. Big round of applause for the team. Yeah. Yeah, I think this is the final presentation and we're about to wrap things up. But before that, you know, we want to thank our esteemed jury panel, who has also shown us immense dedication for assessing these entries. And, you know, for that, please give a big round of applause for the jury members. And also, I want to congratulate all the finalists in the office division. Your hard work was coming out quite well, and you did a great job. Thank you. A big round of applause. So, as a jury coordinator for this division, I've had the opportunity to see the team submit their, you know, submissions, and they have had done some incredible work. And let us not forget that these teams have discovered the way to collaborate and do integrated design during the last 9 months. I think for that itself, it deserves another round of applause. Thank you. Yeah. So this evening, the jury members will meet and decide the winner and the runner-up. So we'll decide who will it be. While we wait in anticipation, don't forget to head to our YouTube channel to vote for your favorite movie. We have extended the deadline to vote till 5 p.m., so let all your team members know about that. We have an exhibition also, which is called the Climate Smart Innovation Exhibition, which will be held in the multiplex, just 5-minute walks from here, where you get to see, you know, innovative building products from the industry that address climate change. The exhibition is open for you now. You can start right after the closing of this presentation. So please proceed to multiplex zone. And for the people who are online, stay tuned to our channel. And at 6 p.m., watch the 10 exhibitors pitch their product in the bid to win the Climate Smart Innovation Award. Until then, have a great evening. Thank you very much.
The big hand for money.